Pog Cube. Your goddamn rap copy pasted. Hello. Hello. Maybe we should put some music on, I suppose. Some smooth jazz. Chat. Do you like jazz? Maybe? Probably. Quite likely. Is that how you do that? Maybe not. I don't know how to use headphones. What's up, our good duck? What's up? Welcome to the shit show. So yeah, let me make a cup of tea. What's up, Bitstream? Hello. So today is Friday, if I'm not mistaken. Am I? I think I'm not. And that means today, according to the schedule, we're doing what? We're doing a random one-off stream. On a random one-off stream, I pick a random topic and I stream it for one stream, usually. Well, sometimes it may actually span several streams, but I don't think I'm gonna spend too much time on this topic today. So I just wanna do a quick in and out on the topic, just to check out these things. So, yeah, that's what we're gonna be doing today. We're gonna be looking into Vulkan, but under the prism of Rust. That's right. We're not gonna be using some old C. We're gonna be using modern Rust. That's what we're gonna be doing. So, and the wrapper, the Vulkan wrapper that we're gonna be using today is the Vulcano, I think. This is the thing that pops up in a search when I search like Rust Vulkan. So, and it has a lot of stars. That means it's good, right? So if it has a lot of stars, that means it's good. So I decided to use it. I checked it on my machine. On my machine, it works. So if it works on my machine, I can probably do something with it, right? I cannot do anything with things that don't work on my machine. It is what it is, and it isn't what it isn't. Works for me, Kikoda. Works in my machine. God damn it. God fucking damn it, mate. Hello everyone. Hello Kinslayer. Hello Lazy Grid. John. Hello. How are you guys doing? How are you guys doing today? This is VK Cube, by the way. This is the demo that comes with Vulkan tools or something, right? And yeah. So this is sort of like a demonstration that Vulkan can work on my machine. I had to like tweak some things in Xorg configuration, but after tweaking them, yeah, it actually worked. So yeah. So what exactly we're gonna do today, I don't know. Maybe we're gonna try to render at least triangle. I heard rendering a triangle in Vulkan is hard enough so that I may have a content for not just one stream, but maybe 2 streams. So, maybe. I've just patched the kernel and it works. Nice. Oh, you mean me? No, I didn't patch the kernel. I just put a couple of stuff to the configuration of Xorg. So I need to enable something that is called DRI3. Whatever that's supposed to fucking mean. I don't know what is a DRI3. I know nothing about computers, but I enabled it in my Xorg configuration and it just magically worked. Go figure. So I don't know if I can know. So I'm gonna go to the kitchen and turn on the kettle, and I'm gonna be back to back champion of the arena. Okay. So, what let's get started, shall we? Let's get started. DMCA. Sweet sound of DMCA. Love it. Absolutely fucking love it. So, how are we gonna call... how we're gonna call the project, right? That tries Rust and Vulkan. So, I'm not quite sure. Jiang, what's up? What's up? Hello, hello. So we need to come up with a name. So maybe Rust, Vulkan, Vulkan, Vulkan. All right, it's a good name. Not gonna lie. Let's do. Do I need to actually update my Rust? Rust app update. Let's see if I need to update anything. Okay, so I'm using the latest Rust apparently. So let's do cargo init. Right, let's do cargo init. So and yeah, so this is essentially what we have in here. So it automatically created a Git for me for some reason, but okay. Let me do cargo toml. See more keys and their definitions in here. Thank you very much. So my tea is ready, by the way. So I'm just gonna quickly pour a cup of tea, and I'm gonna be back to back. Fucking coming. So, as I already mentioned, the binding that we're using today is is called Vulkan. Let's take a look at that binding and see if it's good or not. I checked it out a little bit off screen. I just ran a couple of examples on my machine just to check that this binding works at all on my machine. So let me just copy paste this entire stuff and go to the page of Vulkan. So this one seems to be the closest one to the original Vulkan. You see, it has 2.6k stars. So yeah, it's a Rust wrapper around the Vulkan graphics API. It follows the Rust philosophy, which is that as long as you don't use unsafe code, you shouldn't be able to trigger any undefined behavior. Okay. In the case of Vulkan, this means that non-safe code should always conform to valid API usage. But he doesn't even act like a clown when he's not streaming. Yeah. Anyway. So, what I want to do, I want to try to depend on this entire thing and just go through some of the examples. Let's go to the create. Create, and Vulkan. Okay, so I think I should be able to just copy paste this thing. I can just do it like that and put it into the dependencies, and let's try to do cargo build. And I think I already have like this entire thing pre-compiled, so I didn't think it's gonna take too much time, hopefully, but yeah. Well, apparently it's gonna recompile everything from scratch. Small vec ppl. Well, I mean, while we're waiting, we can drink a cup of tea. That's the point of modern technology. That's the point of modern technology that takes a lot of time to compile. So you can have excuses for your employer to not work, right? And just drink some tea. That's basically the whole point. Rust compile times, exactly. That is basically the whole point. Clown Fiesta already begins. Oh, okay, so it took only 1 minute to just, you know, finish compiling this entire stuff. But I mean, I need to pour a cup of tea anyway, so let me quickly do that. Alright, so let's do cargo run and see if it runs. It says hello world, as you can see. And let me see what we can do in here. The thing I want to do, I want to go to the examples and just do something with the examples. So one of the examples that we have in here is the triangle. Yeah. So the triangle takes 500 lines, 555 lines in Rust, which is a little bit smaller than in C++, because in C++, as far as I know, it takes like 1000 lines of code. So Rust is a little bit more concise than C++. You see? So if you Google up Vulkan triangle example, right? Vulkan triangle example, and you open this thing up, you will notice that this example is around 1000 lines of code. Yeah, it's a little bit more than 1000. How English people say 1200s? Yeah. English people say 1200s, right? So 1200 lines, but this one is actually smaller. So, which is the ultimate proof that Rust is a better language because it's more concise. You can put more functionality in it, right? They're doing the same thing, right? They're doing the same thing, but Rust code is smaller. So it is what it is, and it isn't what it isn't. So let me see. So where's the entry point? In an entry point, we do something called Vulkan win. Whatever that's supposed to mean. Okay, let's actually read this description in here. Maybe I might as well actually... Okay. The first step of any Vulkan program is to create an instance. When we create an instance, we have to pass a list of extensions that we want to enable. Right, so all the window drawing functionalities are part of non-core extensions that we need to enable manually. To do so, we ask Vulkan win create for the list of extensions required to draw a window. So we need to call to something called Vulkan win. And where can we find that? Vulkan win. So I don't see them enabling it anywhere. So Vulkan win. So they only enable VK surface build. So I'm gonna just try to call this function Vulkan win. Oh my god. Yeah, require extension. Let's actually try to query all of the extensions and see what's gonna happen in this particular case. So tense music. Is the music too tense? I can switch it to something else. So if the music is too much, I can actually turn it off. Is it better? So just let me know if the music too much. Alright. Vulkan, and let's try to run this entire thing. And of course, we don't have Vulkan win because probably it's a completely separate crate that you have to depend on. So, alright, it's not enough to just enable Vulkan, right? So you need to separate thing for this entire stuff. Okay, let me see if we can get that crate from somewhere. Vulkan win. Oh, okay, there is. link between Vulkan and w-init. So let's just copy paste it in here and add it to the cargo toml something something, and here is Vulkan win, and we should be able to compile this into STF. Oh yeah, we need, okay, sure, we also need to compile the Vulkan win. Owned TTF parse. Why the name of this crate is so funny? Holy shit. Why is it not pwned? I do understand what they were trying to say here, but it just sounds so funny. It's like, yeah, I fucking installed own TTF parser, just fucking hacked all the way through, backdoored and stuff. I don't know why it's so funny. I think I'm an idiot. Oh, we also have a package called Andrew. Yeah, I've always wondered, what the fuck is Andrew? Like, what the fuck is this package? Create provides a convenient drawing. Ah! So it's draw. Okay. Objects such as shapes, lines, text. But why do I need, like, I mean, isn't this something that you're supposed to do yourself when you're working on such a low level of API? Right, so you have shaders, and you basically receive some vertex data from the shaders, and you just draw whatever figures you want using mathematics, not Andrew. Who's gonna win? The discipline of mathematics or Andrew? By the way, yesterday I created a library called Gym. And I didn't know about Andrew when I was creating this library, but this basically stands for JSON Immediate. It's a library for generating JSON in immediate mode, similar to IMGUI. And yeah, I created it yesterday for my needs, and if anyone is interested, so maybe you can check it out. Just wanted to mention that there's a library Andrew, and I also have my own library called Gym. So yeah. All right. So it's, holy shit! It's still compiling, by the way. So it's still running. So let me double check if I'm not running out of space. I feel like I might run out of space. It's actually kind of dangerous. So I'm gonna split this screen a little bit, and I'm gonna watch on df-h just to make sure that I'm not running out of space, because I only have like a 3 gigs in my home. So I'm a little bit worried that we're gonna have some problems right in the stream. Okay, so we apparently managed to compile everything. So we have queried this thing successfully, and one of the things I want to try to do, I wanted to try to print those extensions. Right, I wanted to print those extensions. Alright, so instance cannot be formatted with a formatter. Okay, so maybe I have to actually print it in a debug mode. So is it even print debuggable? Can I just see them at least? And okay, so these are the extensions that we have. These are essentially all of the extensions that we have. That's actually pretty cool. Alright, so let's go back to our example that we were working on. We created all of these things, and now I need to create an instance. You know what? I'm gonna actually grab this file in a row. Right. And I'm gonna put it somewhere here so I don't have to go to that website, and I can, you know, I can just open it locally on my machine. Right, of course, I want to kind of remove the white spaces and stuff. And where is my entry point? Yeah, instance. So where do they take the instance? Do they get the instance from somewhere? Yeah, it's a Vulkan instance. So this is what they take it from. All right, let's try to do it like this. I'm gonna do this kind of stuff. Instance new. I wonder if I can take a look at the API docs for Vulkan. That would be actually kind of cool, I think. Can I take a look at the API docs? So Vulkan. Maybe I can actually find some docs in here. So there's a cargo folder, right? And I probably can find like a directory. Find type directory with a name that contains Vulkan, right? And in that directory, we might have some documentation. Okay, so here they are. I can probably go there, find file at point, just go there. And we have any docs in there? Okay, so we don't really have any docs in there. And I wonder, can we just generate docs with cargo doc or something for specific packages, but locally? You know what I'm talking about? You know what I'm talking about? Does anyone know how it's done? Probably have to figure that out myself. So I'm pretty sure there's something like cargo doc, right? Doc help. All right. So build the package documentation. Can I specify the package? Okay. Package to document. Okay. So can I do something like cargo doc? Oh, I already forgot. Minus P. Okay. Minus P Vulkan. Okay. So it's downloading everything, and I wonder where it's gonna put that. Like maybe it's gonna put it somewhere. Documenting everything. I also need to keep an eye on my home folder. Just a second. I need to keep an eye on my home folder. Okay. All right, so where did it put it? Maybe it put it in a... Okay, so we have doc. So do we have HTML? Do we have an index HTML? I don't see index HTML. Vulkan. Okay, so we have Vulkan. Do we have an index? Yes, we do have an index HTML. Here's the instance. So we have a dark theme in here, by the way. Can I have a dark theme in 2020, please? What the fuck is this? Disgusting. So preferred dark theme... wait, what? Preferred dark theme, dark? Preferred light theme... All right, so let me see. Oh, the brush to the left. Oh yeah, okay. But I guess it's yeah, it does the same thing. All right, whatever, doesn't matter. Instance of Vulkan context. Okay. So new. Why I'm not in streamer mode? Okay, just a second. I need to switch to the streamer mode. Yeah. Okay. So. New. So. App infos. I think I need to understand what is app info, and maybe not, because everyone just says puts a null in there. So the only thing we need to have here is an extension. An extension is actually a generic thing, so it could be anything, except it has to be row instance extension. Okay, so it's something that is convertible to a row instance extension. I see, I see. Alright. Row instance extensione. Alright, I just wanted to see what's in there. Alright. So just keeping an eye on all of that stuff, and let me go back in here and let me see what we've got. Alright, so we're gonna go back to the triangle and let's create an instance. So to create an instance, we do instance new none required extensions, right? Required extensions none, and I suppose we unwrap in here, but we might as well actually put expected to create a Vulkan instance, but too unlucky, right? But too unlucky, and here is an instance. So there we go. After we're creating an instance, we want to do. We want to just try to run this entire thing and see what's going to happen. Cargo run. Okay, it's kind of interesting that Intel Mesa actually says this to standard output, but we managed to create a Vulkan instance nonetheless. We managed to create a Vulkan instance, which is kind of poggers, not gonna lie. Okay. We then choose which physical device to use, right? In a real application, there are 3 things to take into consideration. Some devices may not support some of the optional features that may be required by your application. You should filter out the devices that do not support your app. Not all devices can draw to a certain surface. Once you create your window, you have to choose a device that is capable of drawing to it. You probably want to leave the choice between the remaining devices to the user. For the sake of the example, we're just going to use the first device, which should work most of the time. Okay, so I guess, yeah, we take an instance and this is very interesting. So we take a physical device and we enumerate it on the instance, so that gives us an iterator. Yeah, that gives us an iterator. And what I'm thinking is that we can try to iterate through all of the devices and just maybe collect them into some vector and just print all of the devices that we have that are capable of drawing things. So I think that would be interesting and educational. So yeah, let's do physical device, enumerate. So it gives us physical device iterator, right? Physical device iterator, and the iterator should have an item, right? It should have a particular item set to something, but I cannot see it because I'm incapable of reading the documentation of this stuff unless I go to the source code. And in the source code, yeah, it's just the iterator over physical devices. All right, so that makes sense. That makes sense. So let me go to my thingy-majingy. So for device in physical device enumerate, and we're going to provide a pointer to an instance. Right, what we're going to be doing here, maybe we're going to print something like print ln physical devices we found, right, something like this, and we're gonna print them like so. So this is gonna be the name, right, and then I suppose the type, right, and in this particular case type is only debuggable, so device name and device type, that's what's gonna be, we're gonna have. Alright, so let's try to run this entire thing, and it does not compile, because I probably need to take an import physical device from the instance, right? I have to import it from the from here. Alright, so let's quickly do that. I think I can just run it from any place. Yeah, I should be able to run it from any place. Okay. Okay. We only found one. Interesting. So, oh, that's actually pretty cool. So if you have several GPUs, this GPU is going to be in the enumeration of these physical devices, and you will be able to explicitly just choose which device you want. And your application will be able to show a menu. We found these devices that support Vulkan. Which one do you want to use? Which graphics card you want to use? Or maybe you want to switch in runtime, right? So you just can pick it and just use it. Right. So isn't it cool? Isn't it cool? I think it's pretty good and cool, isn't it? What other fields do we have in a physical device? So I only know name and type. So let me see. So here's a physical device. Memory heaps, limits. That's a lot of interesting things. API version. So an API version gives you represent a version of Vulkan. Okay. There's also driver version, which is just a number. Extension properties, limits. So give access to the limits of the physical device. I want to take a look at the limits, to be fair. Oh shit, that is actually pretty cool. That is a very type safe of doing that. Right, so you have a type of a physical device, and then of that physical device you can query some things. For example, I want to know on my graphics card, like how many vertex input attributes can I have? Let's just query that. Like, why not? Let's just query that. It's actually very interesting. So we have a name, and we can do something like print ln, and this one is gonna be. I wish I could quickly copy paste this kind of stuff. So it's gonna be something like this, equal to this, and it's gonna be device limits, and it's gonna be something like this. Right, so let's see what do we have in here. So I'm probably not going to compile, probably fucked up something syntactically. Vulkan. 28! So I cannot create more than 28 input attributes. Wait, which kind of makes sense, like why would you need so many attributes? Right, it's usually, and yeah. Because if you have, yeah, you need an array of floats, array of 2-dimensional vectors, array of 3-dimensional vectors, 4-dimensional vectors, and maybe more of this kind of stuff. You don't need too many vertex attributes, to be fair. So that kind of makes sense. Well, is there anything about textures? Nothing about textures though. Max viewports. Is there something about memory? Memory allocation count. Huh. Memory, yeah, so memory allocation count. Let's take a look at memory allocation count. I wonder if we can just print all of the limits. I wonder if we can just print all of them. So let's put it this way, so we don't have to check anything. So let's print all of the limits, and let's see if it's gonna compile. Limits cannot be formatted because doesn't. Okay, so it cannot be just easily formatted. Alright, whatever. So let's continue. So we need to pick some sort of like a physical device. The first one that is appears there. The first one that appears there. So let me see. It's gonna be fn main. So yeah, so the thing that the example does, it just like takes the first one. Physical device, device enumerate, instance, on an instance, next, unwrap, right. And then we can print the device we found. Physical name. Alright, that makes sense. The objective of this example is to draw a triangle on a window. To do so, we first need to create the window. This is done by creating a window builder from the winit crate, then calling the build vk surface method provided by the vk surface build trait from Vulkan win. If you ever get an error about build vk surface being undefined in one of your projects, this probably means that you forgot to import this trait. Okay, thank you so much for telling me that. That's actually pretty cool. This returns a Vulkan swap chain surface object that contains both cross-platform winit window and cross-platform Vulkan surface representing the surface of the window. Okay, so winit is something that is needed for initializing the Vulkan usually. So let me take a look at this stuff. Winit. So, cross-platform window creation and management in Rust. I wonder if we'll have to explicitly depend on it. We probably will have to, yeah. So, we won't be able to create this event loop, as you can see here, without winit. Yeah. So, let me try to do that and just see what's gonna happen. Yeah, it will tell me that this thing is undeclared. Okay. So then I'm gonna go to the triangle, right? To the triangle, and event loop. Right. Event loop is available in here. Right. Event loop is available in here, and let me see what we've got in here. So we only need event loop. So something like this, and it's probably also not gonna compile because. Yeah, we need to have that in the dependencies, so we need to put it into the cargo toml as well. So the latest version is winit 24. I wonder if it's going to be compatible with those things, but maybe I have to use 22 or something. Yeah, let's try to use 22. Maybe everything has to be 22. Let's give it a try and see if it's gonna work. All right. I also need to keep an eye on my hard drive usage. Why are you querying your iGPU? Because I can do that with Vulkan. So basically, what I'm doing right now, I'm just exploring Vulkan. And I'm just seeing what kind of functions this library provides. And I'm just looking into them, right? So one of the functions that it provides me to take all of the physical devices that support Vulkan and look at them. So, and I decided, like, why not look at them, right? Isn't that what makes the programmer, the curiosity, right? You find something interesting, you try it out, see if you can learn something about it. Like I don't usually ask why. I just see a function call that gives me some information. Why not just call it on my machine and just see what's gonna happen? I mean, isn't that the beauty of programming? Isn't that why we're programming at all? Just so we can see some interesting API function in the documentation and just call it and see what's gonna happen? I'm personally programming because of that. I don't know about you guys, but yeah. It's like I don't usually ask why because I'm a programmer. That's what I do. Why are we doing that? Because I cannot make it work on my setup. It's just Debian being Debian. So yeah, and unfortunately, yeah. When I queried all of the devices that support Vulkan, only integrated ones showed up. So nothing much you can do. So I'm kind of limited with what I can do in here. But in any case, we managed to create event loop. Which is kind of cool. And let me see what's going to be the next thing. So it's going to be event loop, right? And the next thing we need to do, we need to create a surface. So that's and we have to clone the instance. That's very interesting. We have to clone the instance. All right. So can I take a look at the documentation somewhere here? Do I have w-init? I wonder, can I just do cargo doc and hope that it will rebuild all of the documentation for all of my packages? I think it's gonna do that. Okay, so it's documented everything. I think that's actually a pretty good idea. Yeah. So let's just document everything and just use the local documentation. So okay. Bloating. My brain just read it like bloating. And I thought that's pretty accurate, not gonna lie. That is very, very accurate, but yeah. So yeah. Nix. Interesting. Is that what is Nix though? Nom. Man, I love the names of these packages. So what the fuck is this? So what about Nom? What about Nom? Let me see. By the range at 0 copy parser combinators. You need a parser combinator in your Vulkan application. That's for sure. Because how are we supposed to parse shit in your graphical application? And of course Andrew, don't forget Andrew. Don't forget the Andrew. What the heck is this? I have no idea. I'm trying to document all of my dependencies. Also, I need to keep track on my hard drive. Okay, so we have docs, right? Do we have w init? There we go. Here's a w init, and let's open this entire shite. So what I want you to take a look at is, I suppose, the window builder, right? So I want you to take a look at the window builder. Yep. Window builder. Okay. Yes. I'm just not sure why you have to clone the instance to build this, but okay. Build VK surface. Let me see. Build VK surface. Yeah, here it is. It's a part of a trait. So the problem is that I don't know how arc works. What is arc? Oh, it's a reference counting pointer. I see. Atomically reference counted. I see. That makes sense. Okay, sure. Okay. So main.rs, and let's create a surface. So it's gonna be window builder, new. Then we're gonna build VK surface. We're gonna provide the event loop, and then we're gonna provide the instance, and we're gonna also clone it. There we go. So, and all of that, of course, has to be unwrapped. Expected to expect it to create a window for Vulkan instance, but too unlucky. And let's just have a surface. I wonder if I can print this. Maybe that will automatically create the window. We'll see. So let's just try to run this entire stuff. It doesn't compile because we don't have a Windows builder. Probably because I have to use it. Alright, I have to use it. So let's put that this window, not Windows builder, window builder. Alright. No window builder. Ah, okay. So just a second. Let me see where is the window builder. Window builder. Yeah, it has to be part of the window. Use the init window. Let's put it here. All right. A method not found on window. Oh yeah, I remember the triangle actually set. Undefined. Yeah. So, to fix the problem that I have right now, the problem is that I don't have a build VK surface, right? So I have to include that. Luckily, oh shit. Luckily they documented that, so I really appreciate it. I would never guess that, but I mean it didn't help anyway, so alright, so let me see what's going on here. Triangle. This returns. Oh yeah, wait a second. Probably means that you forgot to import this trait. Oh yeah, I'm an idiot. Method provided by the case of his build trait from Vulkan win. So yeah, I need to import this one. Yeah. Okay. So I need to import this one, and it's gonna be that one. All right. So let me see. Not found in this. Did I already remove that? Wait a second. Did I remove that? I'm an idiot. I think I removed. So it's gonna be window builder. Okay. So and we don't need this thing anymore. All right. Just give me a break. I really need new glasses, to be fair. I really need new glasses. Okay. Let's start over. Build VK surface, right? So what does it say? Provided by VK surface build trait from Vulkan. If you get an error about being created, okay, so that means you need VK surface build, which I included. Okay. So, but maybe I have to. Yeah, I mean, I copy-pasted this entire thing from here, so that means everything should be okay. This returns object. Okay, so what the problem do we have? Alright. So unused import. So, and that didn't help at all. Alright, so let's make a cup of tea. I think I need a small break. Do you guys have any questions while I'm gonna be making a cup of tea? Thank you, Zhang. Thank you. Turn Alive, thank you so much for subscribing with Twitch Prime. Thank you, thank you, thank you. And welcome to our epic Vulkan club. There's a cool post about the exact problem. Okay, I will look into that a little bit later. I will try to Google that. Thank you, Jane. LVT, thank you so much for 7 months of Twitch Prime subscription. Thank you, thank you, thank you. Sojin cheese. Monk2S, thank you so much for 7 months of Twitch Prime subscription. That's really epic. And welcome to our epic Sojin G's club. I'm sorry, I couldn't help myself. Alright, so I want chocolate, to be fair. I want a little bit of chocolate. But unfortunately I ran out of it yesterday. Yesterday, all my troubles seem so far. I'm sorry. Okay, so I'm gonna go to the kitchen and just make a cup of tea, and turn on my kettle. And I'm gonna be back soon. Making cup of tea. Right, making cup of tea. Alright. So, just a second. Just a second. Okay, so one of the hypotheses that I have is that maybe there is a version is incorrect, right? Version is incorrect. So what we can do, we can check out what version is used in there, right? What version is used in there. So in the examples specifically, because examples do have their own toml, right? They do have their own toml file, and we can just check them out. W init is 24. Interesting. So Vulkan that is used in here is this one, but W init is 24. Pick liquor. Just a second, I cannot hear what you're saying because I forgot to put on my guns. So
some information up here and there. And I am to Adam Foemaka Sai realizet Nidank.
Thanks for interesting stream sorting. I'm still a beginner in many things, but still suck some information up here. Gotcha hyper and there. An M to dump for Emacs, I realized. Thank you so much for 2 months of tier 1 subscription. Speaking of Emacs, just keep in mind that like one important piece of information. Editor does not make you a better developer. So that's the only thing you need to know about Emacs. Right, so every time you have doubts, what editor should I use for that and that? Is Vim a good option? Is Emacs a good option? Just remember one simple thing. Editor doesn't make you a better developer. That's it. Conversation is over. It's just it. There's nothing to discuss in here. Like, it just doesn't make you a better developer. So, it is what it is. Sorry. Just a second, my tea is ready. I'm gonna be back soon.
Now I learned a little bit about real programming static compiled language.
Just a token of gratitude for your streams. Because of you, now I learned a little bit about a real what is real programming? Static compile language. I don't know what is a real programming, but thank you so much for 6 months of Twitch Prime subscription. Thank you. So, all right. Is there like imaginary programming? Yeah. So probably if there's a real programming, there must be an imaginary one. So who knows? But I'm glad that you're learning real programming. What was that supposed to mean? So. All right. Let me see. So they are using winit 24. So let's actually try to use also winit 24. So let me see. Let me try to run that, and maybe that was gonna be a little bit better. Okay, so I guess we know what was the problem. So wait, did you see that? It blinked. That means it briefly created a window and then it exited and the window got destroyed. Alright, so let's take a look at this stuff. The next step is to choose which GPU queue will execute our draw commands. Devices can provide multiple queues to run commands in parallel. For example, a draw queue and a compute queue, similar to CPU threads. This is something we have to manage manually in Vulkan. In a real-life application, we would probably use at least a graphics queue and a transfers queue to handle data transfers in parallel. In this example, we only use one queue. We have to choose which queues to use early on because we'll need this info very soon. Okay, so we not only have queue, we have the whole queue families. It's a family-friendly API. It has queue families. I have no idea what that's supposed to mean, but let's actually read more about that. Family-friendly API, finally. So we'll probably have to have... So let me close all of this stuff because it's... is this what I think it is? This is a Vulkan. Okay, so we need to have a physical device, right? So here's a physical device. And in here, we should have something like queue families. Right, so it gives us a queue family iterator. Right, that we can try to iterate. For all queue families available on a physical device. It's kind of strange that for different kinds of iterators, you have to have like a separate type or something. But maybe, oh, maybe iterator is actually, yeah, I see that. All right. So let's do the following thing. Let's actually try to iterate through all of the families and see how many of them we have and what kind of families we have. So let me see. So for a family in physical queue families, So I need to take a look at a single family. All right, so where is the item? It's kind of strange that I cannot just look up easily an item for the iterator. Like I have an iterator thingy, but I don't see an item definition on the page. So for me to find an item definition, I have to go to the source code, find the implementation of an iterator, and find that it's queue family. But maybe I can... Oh, I think I can unfold this. Okay, so I have to unfold the implementation, okay, and then click on this stuff. But Control F doesn't make it easier to work with, unfortunately. I wonder if this thing is like printable or at least debuggable. I think it should be. I think it should be. Let me see. Is it debug? Yes, it is debuggable. So that means I should be able to do something like print like this, right? And let's just do family and see what's gonna happen. All right. So how many family queues do we have in here? Show me. Show me all of your family queues. Okay, so we've got only one, I think. So Q family physical device is that. So there's only literally one. That's very strange. So, and how can we know what kind of Q is that? Supports graphics. Oh, we can actually check if it supports graphics and supports compute. Let's actually see. Graphics family supports graphics, right? And then compute supports compute. Let's see if it's gonna give us any like useful information about this kind of stuff. Why does it take so much time to compile it? It's just really strange. Oh, it supports both graphics and compute. Would you look at that? Supports both graphics and compute. Whatever's that supposed to mean, but okay. Q-Ska. Ah, it's a family. So it means it's... For some reason I thought that it's a single Q, but it has several Qs inside of it because it's a Q family. Okay, that makes sense. I'm an idiot. So, and that's why you can have a count for the Qs. So we can have Qs count. Right, so let's do something like Qs count. Qs count. Family Qs count. And let's see what's gonna happen. Seductress. That's the name of the song. Q's count 1. But we have only one Q. Rust is my seductress. Anyway. Let's continue. So we find the one. Okay. We find the one that supports graphics and is supported by our surface. That's very interesting. It's a great emote. Yes, it is a great emote. I really like it. I don't remember who suggested it. I think it was Supercuber who suggested it, or maybe somebody else. But yeah, it was a long time ago, actually. It's a really good emote. Just a second, chat. I just have a mild panic attack, so I need to regather my thoughts. And I'm gonna continue. Doing this stuff. So it's kind of strange. Like I have a pretty... Yeah, the reason probably this graphics card doesn't support shit is because it's Intel. And, oh, probably not because it's Intel, but because the support, Mesa support is incomplete. Because you see, every time I run this application, it says that the support is incomplete. And maybe it's already complete, but I'm using Debian, which has like a very outdated software, so yeah. Maybe if I switch to something like Arch. I'm actually like legit considering switching to Arch because I'm kind of tired of Debian and its old software, and yeah, I don't know. We'll see. But I'm too lazy to upgrade like every day and fix the problems every day. So probably won't do that. Because I like my system, like I like to configure system once and just forget about it like completely, like it exists. Don't touch it, don't update it, just like it works, don't touch it. So I think you can do the same thing with Arch, but at some point like you won't be able to update. I haven't updated either of my Arch boxes in months. Yeah, that's what I'm scared of. If you miss a single day, you might as well reinstall it from scratch. Yeah, it's just like, just reinstall it from scratch. I mean, it's just not worth the time. But I mean, I tried Arch really long time ago, when I only was getting into Linux. So maybe the situation changed there, I don't know. I tried a lot of different distros. I tried a lot of them. I'm kind of tired of switching between them. Alright, so let's continue. Let's continue. So triangle, right. So we need to find the first one. So, and we accept the queue by a reference. I always want to call it a pointer, but it kind of is a pointer. Supports graphics. And the surface is supported by this queue. And this entire thing... Oh yeah, so this... It's kind of strange that the surface may return... It returns... Wait a second. Are you serious? So this is a Vulkan. This is another Vulkan. Okay, probably have to do something like target docs w init. Window builder. Okay. Okay, is supported is not even part of this thing. It's part of the surface. Okay, so here's the strange thing. Checking for a support may fail. Returns true if the given queue family can draw. So, and what can fail while... Okay, so maybe you're querying the support, and querying the support may fail. Okay, that makes sense. So compatibility is not... So one of the things you can have in here is not enough memory, or the surface is no longer accessible and must be recreated. Okay, so yeah, sometimes you may not even be able to query a certain capabilities or certain supports. Okay, that makes sense. That's why it returns the result. That's why it returns the result. That makes sense to me. That makes sense to me. Okay, so unwrap or false, right? So, and after that, we're gonna do something like unwrap, and that gives us the queue family that we want to work with. Queue family. Cool. So after we created the queue family, now initializing the device. This is probably the most important object of Vulkan, the most important one. We have to pass 5 parameters when creating a device. Which physical device to connect to, a list of optional features and extensions that our program needs to work correctly. Some parts of the Vulkan specs are optional and must be enabled manually at device creation. In this example, the only thing we are going to need is the KHR swap chain. I guess it's a name of an extension, right? So KHR swap chain is the name of the Vulkan thingy. So what are... Okay. It's kind of funny that the first thing is like points to Reddit. On the 5 parameters for an amateur, yeah, exactly. Sorry, I'm a bit of a graphics noob. Does this have something to do with double buffering? Google explanation could be found here. Okay, so on the Intel website. API without secrets introduction to Vulkan Part 2 swap chain. Okay. Welcome to the second Vulkan tutorial. In the first tutorial, I discussed basic Vulkan setup, function loading, instance creation, choosing a physical device and queue, and the logical device creation. I'm sure you now want to draw something. Unfortunately, we must wait until the next part. Why? Like tutorial 2? Tutorial 2 and we haven't drawn anything yet, but yeah. Anyway. So in Vulkan, a swap chain is an extension. Why? Isn't it obvious we want to display an image on the screen in our application windows? Well, it's not. Well, I do agree that it's not obvious because Vulkan is also a compute API, right? So that means some Vulkan application may never display anything on the screen. You know what I'm talking about? Right, if they only use compute, and we know why you may want to use only compute and not graphics. We know who you are, okay? So, yeah, so this situation may happen. Anyways, asking for chain. Okay. I guess swap chain is basically double buffering, is it not? I think is it not? I think it is. All right. Can show swap setting attention. A list of layers to enable. This is very niche, and you'll usually pass none. The list of queues that we're going to use. The exact parameter is an iterator whose items are queue f32. Where the floating point represents the priority of the queue. Okay, between 0 and 1. The priority of the queue is a hint to the implementation about how much it should prioritize the queues between one another. So queues, if I understand correctly, queues are basically like threads of the GPU, right? And you can, yeah, essentially threads of the GPU. So the list of created queues is returned by the function alongside with the device. Okay. Device extensions. Oh, this is very interesting. So, yeah, it's sort of like yeah, it's extending the record, thingy. I need to make a small break, chat. I really need to make a small break, like really 3 minutes, and after 3 minutes we're gonna continue. Just a second. Alright. Yeah, let's make a small break. You guys have fun. Yo, what's up everyone? How everyone is doing? Welcome back to back. So device extensions. Where do we get device extensions? Let's take a look at it. So it's part of the Vulkan. So okay. Device extensions, and can I go? Oh, okay, I can actually just use. Oh, okay, so I can just use it like that, and then go there. So device extensions, swap chain, and there are a bunch of booleans. That is really strange. Like, what if I? What if there will be new extensions, but I'm using an old Vulkan? But maybe you just upgrade the version of Vulkan and new extensions are going to be available for you there or something like that. I guess it does make sense. So device extension is just a list of extensions that are enabled or available. Okay. Display swap chain, blah blah blah. So I guess we just have to do that. Alright, so let's go to main in here and device extensions, right? Device extensions, and it's going to be khr swap chain true. And do you guys know this syntax? Do you guys know this syntax? It's actually a very interesting syntax, I think. It's kind of like updating the record in Haskell, right? So I think that creates, like, it takes the current record and then it creates a new instance of the record with certain things updated in there, right? So I think something like that. So device extension, and yeah, so you use the default extension, basically none of the extensions. And like JS, I don't know how it is in JS, but I think in JS it's sort of like a spread operator, right? It's slightly different. All right, so let's actually try to experiment with that. So it's going to be main rs. Let's imagine that you have foo, right? And in foo, you have a bunch of things like bar, which is u32, and something like buzz, which is going to be f32. Why not? So, and let's create an entry function. I don't remember. I think you have to do it like that. And it would be nice to maybe derive. Yeah. Shit. Okay. Derive debug. Right. Just to be able to display this entire thing. And let's do foo, where I'm gonna initialize each individual thing. So the bar is gonna be equal to 69, and buzz is gonna be equal to 420, of course. So, and let's try to print this entire thing. Right. So it's going to be something like foo. And if I try to build Rust C main.rs, more like okay, I should stop. Okay, so this is what we've got. So, and I suppose then you can define something like this, where you say, okay, I want to define foo, right, where bar is going to be 23, but everything else is from foo. You see what I'm talking about? So foo is going to be equal to that, but bar is going to be equal to that. So you create a new instance, right, where you modify only one single field, but everything else is the same as in foo. Alright, and that should be alright. Yeah, there we go. So as you can see, buzz is the same as in foo. And that's essentially what we're doing in here, I think. I think that's essentially what we're doing in here. We're taking the device extensions where none of the extensions are enabled, right? And then we enable only one, so we don't have to list all of the extensions, because there's a lot of fields in device extension, right? There's a lot of booleans, right? So, yeah. And I think spread kind of works a little bit differently there, but maybe it is called spread. It's just naming. Words are just words, they're just labels. Anyway, so yeah, once we created that, it's gonna be triangle. And after that, what we need to do, we need to create a device. with a specific physical device and with the supported features and with particular extensions and with the specific queue. Right, and the priority of that queue is going to be half, but I don't think priority matters that much because we have only one single queue. I suppose priority would matter if we had several of them, right, if we had only several of them. Alright, so device, let me actually go and see if this entire stuff compiles. I'm going to do cargo run, and let's actually see. So we don't have device extensions, so if I go in here, it's going to be device extensions is part of a device. It's a Vulkan device. Okay. So use Vulkan device, and we're going to have something like device extensions. They call it struct update syntax because that's what it is. It's a struct update. It's basically similar idea as in Haskell. Right, because in Haskell, a similar example would look like this. Just a second. It's going to be main. Bodyboard TV. Hello, how are you doing? Very glad to see you. So, yeah. So you would have something like this. Data foo. So this one has to be Haskell mode, I suppose, but it's not really in Haskell mode for some reason. Okay, white space and foo bar int. Right, foo bar int. And then buzz float deriving show. Right, and the way you would update a foo, right, so we have a foo, which is foo bar equals 69 and buzz equal 420, right, and bar is going to be basically foo, but you want to update specifically one thing in here, so you're essentially reusing it from here. So it's more of a like a update of the particular record. So I think this idea was taken from Haskell, but I don't know, maybe it was not taken from Haskell because it's not that new of an idea. I think ML languages like a Camel also have a record update syntax. It's essentially like a very functional idea of instead of mutating a structure, you create a new structure based on the previous one. So yeah, it's a very pure functional thingy. So yeah, if you know what I'm talking about. Purely functional thingy. Alright, so we have a device extension, and can I print the device extensions just to see what's gonna be there? Device XT. Help consider removing the borrow queue. Okay. Okay. I think in the triangle example they do borrow it, don't they? I swear to God, they do fucking borrow it. Oh, they don't. Okay, I don't know why I decided to put in here. Maybe my brain saw this pattern and somehow translated it to here. So I'm not sure what exactly happened. But yeah. Okay, so let's actually save it in here. So, and if I take a look at what happened now, yeah, we only have... Oh, that's actually pretty cool. It has a custom printer. So it only prints the extensions that are enabled. Okay, that's pretty cool. All right. So this is a triangle. Device ext. So what I want you to do, I want you to take a look at the device itself, right? So because we're calling to device, and I need to get used to using only this thing. So and it also returns device, not a physical one, but a new, like a logical device, I presume, and queue situator. All right. So let's go ahead and do that. So device mutable queues, device new, and the things I provide the physical device, and then the features of the physical device. I don't really understand why I have to provide these features like that, but maybe, yeah, maybe I want to provide like a subset of the features, not all of the physical features, but sometimes a subset of them. So yeah, and then I have to provide device extension and the queue family, right? And the this thing. Finally, good music. Okay. Yep. Cool. So, and then I can unwrap this entire stuff. So we managed to create device and queues, hopefully. Right, so let's see if this entire thing compiles. So, okay, we also need to import the device then. So I think this is where we have to do that. It's gonna be device. All right, seems to be doing something. Seems to be doing something. It takes so much time to compile everything. I don't even know what exactly it's doing, but yeah, it's doing something definitely. Alright, so what's gonna be the next thing? Yeah, since we can request multiple queues, the queues variable is in fact an iterator. In this example, we use only one queue, so we just retrieve the first and only element of the iterator and throw it away. Okay, that makes sense. So that's the queue that we're gonna have in here. So yeah, and if I take a look at the queue, so that should be it. All right. It's mining and swap chain, duh. Yeah. I see. It's also mutexes and stuff like that. All right. Sure. Okay, the next one. Before we can draw on the surface, we have to create what is called swap chain. Creating a swap chain allocates the color buffers that will contain the image that will ultimately be visible on the screen. These images are returned alongside with the swap chain. Alright, so this is like a huge section of creating a swap chain. And the size of this section is 43 lines. Including different comments and whatnot. And the result of this block is going to be a mutable swap chain, and I suppose the frame buffers or images. Right, yeah, so these are color buffers. So yeah, that's pretty interesting. Surface capabilities. Holy sh! That's how you create a swap chain. That's how we do that. That's how we create a swap chain. Whatever that's supposed to mean. I suppose, yeah, so essentially there is a notion of a double buffering in graphics, in computer graphics, right? And essentially, if you have two buffers, you can swap between them, right? But you can have triple buffering. Right, you can have a triple buffering, and instead of swapping between them, you essentially rotate between them, and they form some sort of a chain. And so to generalize this idea, you can have a swap chain, right? So you can have a swap chain of two buffers, maybe swap chain of 3 or 4. Is my logic correct in here? Is that the logic behind the name swap chain? So it's a generalization of double buffering on any amount of buffers. Do I understand that correctly? Do we have any professional Vulkan developers and Rust developers in the chat who worked at Feiang and earn a lot of money every day? Do we have any of those people who can answer that question? So I don't know. Anyways, all right. So let's create a swap chain. Let's create a swap chain. Okay. Swap chain images. Maybe right now I'm gonna just make it a block, because sometimes I want to just test some things. So I take the surface and I query its capabilities, right? I query the surface capabilities based on a physical device. Alright, so these are capabilities of the surface based on the physical device, and here are my capabilities that I can try to print now, hopefully. So it's gonna be caps. Alright, so let me try to run this entire thing. Okay, swap chain with 2 buffers is a double buffer. Seems about right. Okay. Alright, so that explains everything. So we've got capabilities. Alright, that's cool. So the next thing, the alpha mode indicates how the alpha value of the final image will behave. For example, you can choose whether the window will be opaque or transparent. Alright, to have that, I need to take the capabilities and supported composite alpha, iterate, so I and then I just use that. Alright, so then I do alpha, and there we go, I have an alpha, and if I try to print that, what is it gonna give me? Opaque. Cool. What if I iterate through all of these like capabilities, right? A composite alpha, because it's an iterator, right? I'm kind of like curious. What the fuck is that? Like why do we pick the first one, and what are the rest of them? What are the rest of them? I'm really curious. What are the rest of them? I wonder if there's too many of them. Oh, so there's only 2 of them. Opaque and inherit. Interesting. Opaque and inherit. Alright, so we're gonna pick the first one. And we have to always pick the ones that are returned by supported ones. We don't want to use the things that are not supported, right? So we have to be super careful with all of that. Okay, so choosing the internal format for the images we'll have. And we just pick the first possible one, and what's that? And the question is how many of these formats we have. How many of these formats do we have? Let me see. Right, of course we have to wait until it mines all the bitcoins on our machine. Okay, so this is the format that we're gonna use. So we're gonna use 8-byte for blue, 8-bit for blue, 8 bits for green, 8 bit for red, and yeah, this is the format that we're using here. So cool. But I wonder what other formats do we have? What is even supported formats? Can we just print this entire thing like that and hope that it will give us? Maybe it's a vector or something else. So let's find out. Okay, so we actually have 2 of them, 2 supported formats, RGB and norm. Okay, I guess it makes sense to pick the first one. What's up, Benny Darshan? Hello, hello, how are you doing? Okay, so we're just picking the first one. Sure, I'm okay with that. The dimension of the window only used to initially set up the swap chain. Note, on some drivers the swap chain dimensions are specified by caps current extent, and the swap chain size must use these dimensions. These dimensions are always the same as the window dimensions. However, all the drivers don't specify a value. Caps current extent is none. These drivers will allow anything but only sensible value in the window dimensions, because for both of these cases the swap chain needs to be the window dimensions. We just use that. Okay. So I guess we just need to query the dimensions of the window, just in case, just so we can initialize the swap chain. So, and it's gonna be just an array of two 32-bit numbers. So we take the surface, we take the window, and we take its inner size, and we converting it into an array of these two numbers, right? So, and I guess we gathered everything. So please take a look at the docs for the meaning of the parameters we didn't mention. Okay, so we are creating a swap chain now, and there's a lot of parameters in here. So are you guys ready? Are you guys ready? So let's go and take a look at this thing, swap chain. So here's a swap chain. Contains the swapping system and the images that can be shown on the surface. And here is the entire thing. So you provide the device that will recreate it. You provide the surface that we created with Vulkan Win and we init. So the amount of images that we want to create, I suppose is going to be... Oh, we're using minimal image count. I presume that it could be actually 2. Would it be? Let's actually check it out. It's actually a pretty cool idea to try to look into those images. All right. So it's doing things. Well, it's compiling the source code, and yeah, it's 2. Right. So in our case, it's going to be double buffering, right? So because it's caps mean image count equal to. All right, so format, we know the format. Dimensions are the dimensions of the window. Layers, layers. We're gonna have one single layer. I'm not sure what the fuck is a layer though, but I suppose maybe you can have several layers. Oh, returns the number of layers of the image of the swap chain. Okay, so a single image within the swap chain can also have several layers. That's very interesting. So within a single image you can just have multiple images, I suppose. And then we have image usage, and image usage is what? Yeah, I guess it's just like different parameters on how you use the image usage color attachment. Okay, so then we provide the my mouse has died, actually, believe it or not. My mouse has died completely. My second mouse that completely died, unfortunately. Okay. It's also color space. Okay, I more or less understand what is going on. More or less. Okay, so let's actually go ahead and just copy paste this entire thing and just return the result of this entire stuff. To be fair, some of these things could be probably inlined, but I'm not sure if it's too much. So let me see if we can just do that. Okay, so one of the things we didn't have a surface transform. We didn't have a surface transform. Let's actually see if we have it here. It's a Vulkan swap chain surface transform. Okay. Use Vulkan swap chain. So we need to have that. And of course I forgot the semicolon. Yesu. It's a present mode. Present mode. It's gonna be something like this. It's also part of the swap chain. I'm gonna assume that everything is sort of part of the swap chain. Okay, so present mode. Okay. Okay. Color space. I'm not sure about the color space, where color space is located. And swap chain itself is located in the swap chain, of course. Image usage color attachments. So it's actually Vulkan image, okay. Use Vulkan image usage. Okay, so now I have to go back to my original triangle thingy. And just do something like this. And what do we have in here? I forgot a semicolon. And I think finally it compiles. I think we managed to create a swap chain. Okay, maybe it would make sense to actually print the swap chain and see what is going on there. Swap chain, there we go. So let's wait to happen for now. You cannot just print that because it's not. Oh yeah, semicolon. Okay. Okay, Vulkan swap chain. We fucking did it. Alright. We now create a buffer that will store the shape of our triangle. So, okay, so... yeah, so this is a buffer. CPU accessible buffer. Huh. Oh, so you can define a vertex type and then mark it for the Vulkan to be a vertex type. And it will treat it as a vertex type then later, so you have to inform this library about this kind of thing. Okay, makes sense. It's kind of interesting that you have... Okay, so that makes sense. Oh, we have shaders. Yeah, this is the coolest part here, by the way. So you can have shaders, the compilation of which fails at compile time of the application. Right, that's actually pretty cool. That is actually pretty cool. So they fail at compile time of the application. Okay. Maybe I want to make another cup of tea, probably. Oh, I want to make a small break because it's like really intensive. Like the amount of information and amount of stuff that you have to remember is just like really exhaustive. Does anyone have any questions, maybe? So I'm gonna just like chill a little bit because it's too much stuff. How are you guys doing? Do you guys program in Vulkan professionally every day at your Epic Fang company, using only Rust and nothing else, pushing the industry forward? Yeah. Working in crime. Yeah. Yeah, it's pretty much the same for me too. My company uses OpenGL, but there are a few who keeps mentioning Vulkan every day. Do they also mention Rust every day too? And I program in Visual C++ 2008 using DirectX 9 API. That's the best kind of setup that you can have, I think. But I got the triangle rendering with the writing my own bindings. Good. I'm gonna write all of my C++ physics code to Rust now. Nice, finally. Is it safe programming inside Vulkan? Yes. It's not safe outside, but inside is pretty safe. Not yet, but I'm sure they will mention Rust on the Rhythm video article about that, yeah. So, I'm a little bit hungry, to be fair. Maybe I need to eat something. So let's make a cup of tea, maybe. It's really funny how so many people were asking me, Zozin, when you gonna do Vulkan and Rust and all of this shit? I'm doing Vulkan and Rust. And everyone just realized how fucking complex and difficult that is, and they will just bailed out instantly. Like, so there was like a 230 people, and okay, yeah, all right. So in the left, it's just so fucking funny. Like, people just repeat shit on the internet that they hear on the internet without even realizing what they're repeating. Like, so they don't even know what they're talking about. I'm gonna fucking upload this thing on the internet. On the YouTube. Every time somebody's mentioning Rust or Vulkan, it's just like, go watch that VOD in its entirety. I created it for you. Good luck. So... What's up, Combi? Hello, hello. Alright. What do we got? What do we got? So now we need to create a vertex buffer. Vertex buffer. Okay, struct vertex, and it's just a position that is of 2 values. Then I can do Vulcano implement vertex vertex position. There we go. So after that, we have to use CPU accessible buffer. I have no idea what is a CPU accessible buffer, but I'm gonna try to search it here. Okay, so here it is. So this is a CPU accessible buffer. Buffer whose content is accessible by the CPU. Setting the host cached field, blah 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 blah. Okay, cool. It uses from ether, if I can see it correctly, from ether. So we provide the device buffer usage, whether it's host cached or not, and so on and so forth. Alright, so CPU accessible buffer from ether, right? So it's going to be device clone, and then buffer usage all. So I want to take a look at the buffer usage. What does it mean exactly, precisely? Describe how a buffer is going to be used. This is not just an optimization. If you try to use buffer in a way that you didn't declare, a panic will happen. Some methods are provided to build. Okay. Transfer source, blah blah blah. Okay, that's cool. It's not an optimization. It's just like you know, permissions and whatnot. So we're gonna have all, and the other thing, so from ether host cached, it's not gonna be host cached in our case, and the last thing we provide the data itself. All right. So, but since it's an iterator, so we have to we do convert it to an iterator. So this is gonna be our vertex, but our triangle, but their triangle is actually kind of dumb in my opinion. So I rather prefer like -5, -0, 5, -0, 5, 0, 5, -0, 5, and 0, 0, 5. So we're gonna use that triangle instead. So this is gonna be position -0, 5, -0, 5, right? So let me actually do it like that. The other one is going to be the positive one, and the other one is going to be this one. There we go. Something like this. After that, we're going to be converting all of that to an iterator, and we're going to be cloning it for whatever reason, because it needs to be cloned. Okay, So, so and after that I can just close this entire thing and unwrap it, and that should be the result. So can I just format, like Rust format? I can only format the buffer, okay, and it can't even format anything properly. Alright, so that's semicolon. I think instead of semicolon here you have to have this thing. Can I format it now? It looks like I can format it now. Cool, cool, cool. Alright, so let's try to compile this entire thing and see if it's gonna work or not. It does not really work because why we don't have a CPU accessible buffer. This is because it's located in here. So it's Vulkan, this thing. Vulkan, this thing, and let me see. So it's a buffer, CPU access, blah blah blah, and let's try to recompile this entire stuff. Buffer usage is also not available. I think I can find it here. It's a Vulkan buffer. Okay, let's go here, and I'm gonna do it like that. Was it buffer? Buffer usage? Yeah, it's a buffer usage. There we go. Buffer usage. Okay, so what's the next thing? So we'll kind of int vertex. Okay, no function associated with the default something. Oh yeah, we'll probably have to do it like that. It's gonna be derive default. Right. So can we have a default value? All right. So do we have any errors? Okay, so I think we managed to compile that successfully. Okay, so can I now try to print the vertex buffer? I'm trying to print the vertex buffer. Okay, it's not printable apparently. Main vertex cannot be formatted with... Oh yeah, maybe because I have to like make it like a debug. Right, so maybe then it will be formatted properly. Okay, so here is the CPU accessible buffer, and yeah, we have all of this shit. Okay. So what's gonna be the next thing? So this is gonna be a triangle, and we need to create the vertex shader. The next step is to create the shader. The raw shader creation API provided by Vulkan library is unsafe for various reasons. An overview of what the Vulkan shader macro generates can be found, blah blah blah, whatever. So we just need to create two shaders. So this is going to be vertex shader, and the vertex shader, as far as you can see, it just passes the position it receives from the vertex buffer to the fragment. Right? It doesn't really modify it in any way. Yeah, it would be kind of interesting to maybe add some uniforms here, like a time uniform, and animate, like rotate it around or do something with it or whatever. And yeah, and the fragment shader doesn't do anything except setting the color for the triangle to red. Right, so yeah, it's pretty straightforward. So I'm gonna go make a cup of tea. And we're gonna continue. I think we're really close. I do think we're really close. We're already creating the shaders. Then we need to create something called render pass, whatever that's supposed to mean. So then we have to create a pipeline. So we have to create a dynamic state. Then we have to create a frame buffers. So we have a special variable for recreating swap chains. Maybe they could be recreating during event loop. Okay, and then we finally organizing the event loop, and within the event loop we should be able to do all of this stuff and call shaders and whatnot. And yeah, so as you can see, it's a very simple and straightforward API. It's actually very simple and straightforward. You just need to create all of these things and it should just work. So yeah, that's pretty cool. I'm super excited about it. But first we need tea. So just a second. Yeah. Making cup of tea. Okay. Alrighty. So, alrighty. Do you guys have any questions, maybe? Do you guys enjoy the Vulkan programming in Rust? I think it's pretty cool. I think this is the future of software development. I think everyone should jump on this Vulkan Rust train and rewrite all of their applications in this beautiful technology to make it safe and more modern. So I think it's amazing. It is in fact absolutely amazing. So I absolutely love it. And the fact that it's so simple and accessible, like anyone can just download this entire thing and start using, is just amazing. Like, yeah, it's all free, it's all easy to grasp. There's a lot of tutorials, you can just learn all of that. It's just amazing. It's absolutely amazing. I think I absolutely in love with this technology. So yeah. Well, yeah, I'm just dead inside already. So, I'm just waiting for my tea. It takes way too much time for some reason. I don't quite understand why does it take so much time. Swoop chains. So swoop currencies. Right. Swoop currencies. Oh shit! I forgot my. Just a second. I'm back. Too back. Physical device. So let's continue developing this shit. Let's continue developing. So we stopped at creating vertex buffer and we successfully created a vertex buffer. So the next thing is to create the shaders, right? We need to create the shaders. So they're creating the shaders in a separate module for some reason. Probably because, yeah, probably this thing expands to a bunch of things. That's why it's a separate module. Fair enough, fair enough. So let's put this separate. It's kind of cool that you can have nested modules within the functions. So it's like a temporary module, but I mean it's just like a namespace in this particular case. So Vulkan shaders, shader, and this is a macro that we're using. So the type of the shader is going to be vertex, and source is this. All right, so yeah, can I just put this thing like that? So the JLSL that we're using, so I suppose the JLSL we're using is 450, right? And I suppose the support for that JLSL is provided more by the JLSL compiler, right? Because as far as I know, in Vulkan, so the compilation of the shader happens before the execution of the program. So there's a special JLSL compiler which generates SPIR-V or SPIR-5, I don't know how to pronounce this thing, like bytecode, and you work directly with the bytecode rather than the source code. So this entire thing should compile at the compile time of the application, so unlike in older OpenGLs. Okay, so layout, allocation 0, and this is going to be input for the position. Okay, so void main, and we're not doing anything particular in this case. We're just passing the position to the fragment shader, right? So this is going to be position. Right, here's position vec4 position, and there we go. So that's the entire shader. Let's try to compile that and see if it compiles even. It doesn't even compile because we don't have Vulkan shaders, because it's probably some sort of a crate. And maybe this is the crate that we have to, yeah, we have to use it separately. Yeah, it's the latest shaders thingy. So let me take a look at the crates IO. So let's take a look at the crates IO. So let's go Vulkan shader. And kind of the music is kind of annoying, so maybe I'm gonna actually turn it off. Like, I'm sorry. It's kind of difficult for me to focus on this kind of stuff while this music is playing all the time. So let me take a look at Scargotoml, and so this is basically what we're gonna have, and I wonder how much time it will take to compile this thing from scratch. Let's see. So downloading crates, and yeah, so let's just have a cup of tea. So we added another crate, and this is compilation time, just to compile some shaders. Oh, I remember this thing. I do fucking remember this thing. This thing took me so much time to compile. Oh, it also uses CMake, and yeah. God fucking damn it. All right. Do you guys want to talk about anything? You guys, how are you guys doing? All right. So do you guys have anything to say? Like maybe with some questions or anything else? How are you guys doing? MonkeyOS. So many questions that asking them will take over the stream. I mean, we have nothing to do anyway. We're just waiting for this thing to compile, so feel free to ask them. So, do you have any questions? Shut. Do you have any questions? How do I get trusted? By not asking about it. So, I guess you already not qualifying. I'm sorry. Kichrutra, thank you so much for a Twitch Prime subscription. Thank you. And your first subscription, by the way. And welcome to our epic Rust Vulkan Club. Rust Vulkan Club. Or you can also subscribe. So subscription grants you automatic trust everywhere. Is it really compiled right now? Yes, it is compiled right now, believe it or not. it's compiling the whole shader C system or something. What's Vulkan? It's a graphics API. How are you enjoying Vulkan so far? Let's not talk about it. It's a species in a Star Trek? I never watched Star Trek, so I know nothing about it. I never watched Star Trek at all. Oh, okay. So you lied. So these are not species from the Star Trek. That's actually a pretty interesting way of answering. Like, you can answer that to any question. What is X? And you can just answer. It's just a creature from the Star Trek. Like, I never watched it, but I'm pretty sure it's a creature from Star Trek. So. Sarimon, what's up? Sarimon Osama, how are you doing? How are you doing? How's your Friday going? Hello, hello. We're compiling shaders again. So far, we managed to create swap chain. We haven't got to the triangle yet. We haven't got to the triangle, but we managed to create swap chain. Rust is great. I love Rust. Cheers. This really reminds me of Thomas the Tank Engine song. I never watched Thomas the Tank. Is that a creature from Star Trek? I'm sorry. I know what it is, but I really never watched it because I think it was never a thing in Russia. Yeah, it was never a thing in Russia when I was a kid. So you do be rusting. Shaders do be rusting. Is this reason everyone promote Rust to have more time to waste? Yes, exactly. Imagine deploying that at your work. How many coffee breaks you can make? It's insane. Is it normal this takes too much alcohol? Yes, it is normal. And we haven't got into drawing a triangle yet. We haven't even created everything that is needed to draw a triangle. We're not there yet, but we're slowly getting there, so don't worry about it. So it is actually running something because you see compilation run. So if this status will become like finished or exit or failed or something, it says run, so that means it keeps running. And these numbers are how many errors and warnings and infos were detected. It actually people running process. To be fair, Star Trek has Android, so Thomas could exist on it. Yeah. Alright, so maybe I'm gonna just do something like waiting for crates do be compiling. Okay, so this is what we're doing in here. Oh, programming is a waste of time. The entire programming industry is just to suck up money from people and their resources and their time and their lives. Like, just this entire industry just sucks up everything. It just sucks in general. That's what I can say. You're sure you aren't stuck in a compile time loop? I don't think so. I already compiled this specific package before the stream just to test things out. And I know that this specific package does take so much time to compile, so we just have to wait. We just have to believe. Right. The same way you have to believe in OOP and the same way you have to believe NFP to improve the maintainability of your project. You just have to follow the rules and your project will become so maintainable. And if it doesn't become maintainable, it's your fault. You just didn't follow the rules properly. So yeah, you just didn't decompose your hierarchies well enough, right? So yeah, you just have to believe. Does anyone have any questions? Manipulaev, hello. What's up? What's up? Does anyone have any questions? Some interesting, maybe on-topic questions? What's up, Rolf? Hello, hello. Hello, hello. What color socks are you wearing? Why do I assume that I'm wearing socks? Nah, I cannot show feet because it's MongoDB actually. So I think I heard people getting banned for doing that, so I'm not gonna do that. Is it really? Yeah, because of the fetish. So it's considered like sort of kind of like a sexual content, to be fair, which is kind of strange, but I mean, I don't know. I heard just rumors, so I better not to risk it for the biscuit. Okay. Do you think Vulkan was created for corporations? I have no idea who it was created for. I think it was created to torture people. Can you show banana on stream? Not on today's stream because I ran out of bananas. I'm sorry. But I showed banana on my stream before. And I even ate it on the stream. And it was pretty delicious, not gonna lie. But yeah. Writing sudo clone is quite easy, actually. Dosu. Okay. Supposed to be easier than OpenGL. I haven't used either, so I don't know. Okay. How do you enjoy the Vulkan stream so far, guys? Is it interesting? Is it educational? Have you learned something new? Do you guys think it's going to be the future of software development and computer graphics while we're waiting for the compilation? Yeah. Share your opinion down below. So I actually want to extend a little bit so we can see the compilation running. We're going to rust in place. Yeah. To be fair, I think Vulkana as a binding is a little bit too thick. I think it's too thick of a binding. It could be a little bit thinner. I could imagine the Vulkan experience in pure C being a little bit more comfortable than this. Vulkan seems to have too many dependencies for what it's doing. Like in an attempt to make safe bindings, which is maybe it's important for some use cases. I don't know. Whatever is causing that Intel master thing seems to lock your compilation all the time. How do you know that? Did you log into my computer and troubleshoot that, or I don't know. What makes shader C's so compile heavy? I have no idea. Do I look like a Vulkan developer? Do I? I don't know. I'm using Vulkan for the first time in my entire life, and I started with Rust, by the way. Yes, my first ever Vulkan experience is in Rust. No fucking joke. So I've never did any Vulkan before. Yeah, I do have a degree in Rust. Can you run top? Yeah, the top is will just show you that all of the cores are taken. I already compiled this thing before. I know what is going on, so we just need to wait, you guys. No need to help me to troubleshoot the problem. I already been there, so I kind of know what's going on. But what's funny is that during the stream, I think it's gonna take a little bit more time because I'm streaming, so I don't have that many resources on my computer. So yeah. I wanted to say something, but I forgot what I wanted to say. Oh yeah, so degree in Rust. Whatever. We're following the tutorial from Vulkan binding library. Yeah, that's exactly what we're doing. That's literally exactly what we're doing, nothing else. It seems like it's compiling C library. Yeah, because shader C is the C library, as far as I know, is like a project for, like by Google for compiling shaders or something. It's just for Vulkan thingy. And I think it's compiling this entire thing from scratch. So nothing much to say, it's just compiling this thing. Maybe you guys have any questions, some interesting questions maybe, while we're waiting for this thing to compile. Oh, now I understand what you're talking about, vulcanization. Okay, holy shit. Took me some time. Why nobody rewrites shader CCs in exactly? Why nobody rewrites everything in Rust? Why are we still using these old as insecure languages? Everything has to be rewritten in Rust. That's right. You see? You see what I'm talking about? You just have to believe. You just had to believe, and it's almost finished. All of the non-believers, mods, ban all of the doubters. Ban all of the doubters and promote all of the believers. Yeah. Okay, as you can see, it works. So what we had to do, we just had to wait a little bit. We just had to wait, and we finally compiled everything. So let me see. So this entire stuff was needed just to compile this shader. As far as I know, if you put a compilation error in here, it will not compile because it tries to compile the shaders at compile time. Yes. Look at that. And the error message is completely irrelevant. Nice. I really like the fact that it only points here, but it never tells you where within this entire thing the error has happened. Yeah. Cool. Thank you very much. Yeah. So, but it would be kind of cool if we had a macro, right? If we had a macro that also, when it fails, would tell you precisely in this file where a thing has happened. that is something I would really appreciate, because, but this is, I don't know. Okay, so we have this thing. So the next thing is going to be fragment shader. Right, next thing is going to be fragment shader. So mod fs Vulkan shaders shader, and the type of the shader is going to be fragment, and the source of the shader is going to be what? So in the source of the shader, we just do a very simple thing. Version 50. Layout location and the output vec4 f color, right? And 1 2 3 4 void main. It's so convenient to use Emacs for this stuff. F color vec4. So we just set it to red, right? So we just set everything to red, and let's try to recompile this entire thing and hope that it will in fact compile. Now keep the target photo like a treasure. Well, oh shit. Alright, so everything seems to be compiling. Okay, let's take a look at the triangle. So after we compiled all of the shaders, right, after we compiled all of the shaders, we have to load all of them. I see. So interesting, yeah, so it generates a bunch of code within the module. So we have to, yeah, we have to do it like that. Okay, so I suppose I'm gonna do let vs. I take vs module, and I load that shader with the device. I have no idea why I have to clone the devices all the time, but I mean, sure, why not? And the next thing I want to do, I want to try to print that shader just to see if we manage to create it in any way. And it doesn't seem to be very printable, right? Because it's not debuggable. Okay. Fair enough. For the fragment shader, we're also going to have a fs, and yeah, I guess that's going to be all right. So we're going to be loading all of the shaders. What the hell is shader? Shader is a program that runs on your GPU. So there are programs that run on your CPU, and the programs that execute on your GPU we usually call shaders. It's a rough idea, not precisely, but it's a good approximation. Okay, at this point, OpenGL initialization would be finished. However, in Vulkan, it is not. OpenGL implicitly does a lot of computation whenever you draw. In Vulkan, you have to do all this manually. The next step is to create a render path, which is an object that describes where the output of the graphics pipeline will go. It describes the layout of the images, where the colors, depth, and / or stencil information will be written. Do you guys know what is a stencil buffer? Do you guys know what is a stencil buffer? So stencil buffer is almost like a Z buffer, right? If I understand correctly. I've never actually used a stencil buffer, but it's almost like a Z buffer. And I already explained what is a Z buffer, right? So essentially you have a color buffer, which is image of the pixels that you're displaying. But with each pixel, you can associate the Z value of that pixel, right? And as you associate the Z value of that pixel, when you draw more polygons on your image, you can compare the Z values, and some of the pixels can be removed completely because they are behind other pixels, right? So it's a Z value on the level of each individual pixel, and that way in 3D graphics application you can see two polygons actually penetrating each other quite nicely, because there's a Z buffer that basically cuts off parts of the planes and stuff like that. Stencil, as far as I know, I'm not sure if I pronounce it correctly, but I think this is how it's pronounced, how this word is supposed to be pronounced. It's a generalization of that idea. So what if we're not gonna have only z, but any kind of values, right? So maybe it's not gonna be z, maybe it's gonna be something else, whatever you want. And the pixels are gonna be cut off not when z is bigger or smaller than another z, but by your own rules. What if you define the rules when these sort of pixels could be cut off, right? So, and that's what is stencil. So basically it's your own customizable like a z buffer, but not only for z, but for anything, right? And that way, one of the classical examples of using a stencil buffer is when you're create a reflection, right? So I think stencil buffer reflection, right? Planar reflection uses stencil buffer. Yeah, there is a pretty good example that shows that. Yeah, essentially, look, you have a scene, you render the same scene on the other side of the mirror, and then with a stencil, you cut off everything that is outside of the mirror. You see? So this is not Z, but it's something else, but it also uses the same mechanism of values on the level of pixels to actually cut off some of the pixels, right? So yeah, that's basically what is a stencil and how it's used. Yeah, that's basically what it is. Does it make sense? Does it make sense? All right. As a buffer for individual pixels, a pixel buffer, if you will. Yeah. Like an alpha mask, sort of, but not only alpha, you can customize the behavior. Alpha is a very specific thing, right? So it's specifically transparency, but you can use it for whatever you want and with whatever rules you want, right? So it's like a more general version of that. Okay. So we need to create something that is called render pass. So we need to make sure that our render passes. That's for sure. So how can I even start all of this shit? So single pass, render pass. And we also have to do that inside of arc. And that arc is going to be... Okay, so let's just go and implement that. Let render pass arc new, and this entire thing doesn't have to be unwrapped. Okay, so we're gonna put a semicolon here and Vulkan single pass render pass. Okay. After this stream, I'm definitely trying Vulkan in pure C. I'm 100% trying Vulkan in pure C. Seriously, because it's kind of interesting. I think in pure C is going to be a little bit easier to work with. A little bit, not too much, but maybe a little bit. So we're going to have that. Then we're going to have attachments. Color is a custom name we give to the first and only attachment. So we have a color, a load clear. I have no idea what is going on here. I don't even know what to start from. Like where. Okay, so am I at the right place? I think so. This is this single pass render pass builds render pass object whose template parameter is of indeterminate type. All right, so we have to do attachment and okay. I love Rust. It's so straightforward and easy to understand. I absolutely love it. It's just so good. Alright, so we have attachment and I have a pass. How does Rust... It feels absolutely amazing. Everyone should use this language. And everyone should ditch C and OpenGL. Use only Rust and Vulkan. Trust me. This will change your life forever. Seriously, stop using all of these old ass technologies. Use Rust. It will save your life. Okay, so this is a store and we use the format swap chain format. samples one. Do we have anything else? I don't think we have anything else. So then we use the color and depth stencil is this thing. Okay, so we did a thing. Okay, so did a thing. I honestly think you just have an issue with... What are you talking about? I don't have a single... Where do you see a single issue so far on today's stream? What are you talking about? Everything compiles so far. Everything works. Excuse me? What the hell are you talking about? Maybe you have issues. I don't know. I don't have any issues. Everything works perfectly. What the hell are you talking about? Alright. So, render pass, and yeah, let me see. Okay, so not found in this particular case. So what we need to do here, we just need to import the arc. Right, we just need to import the arc, and I think it's NSTD sync. Okay, so the example itself is probably imports it from like our, yeah, so they use it from a sync. Okay. Let's put it here. Looks okay. Let's recompile this stuff. Okay, cannot be formatted using... I mean, okay, at least it created something. At least it created something, which I'm super happy about. Honk honk. Okay, so let me see. Everything seems to be compiling. Okay, cool. Triangle render pass. So we created a single render pass. Before we draw, we have to create what is called a pipeline. This is similar to an OpenGL program, but much more specific. OpenGL program, but much more specific. Okay, that's interesting. So graphics pipeline. So we need to indicate the layout of the vertices, input single buffer, so then a vertex shader, then a triangle list, viewport dynamic scissors relevant, okay. So there's also dynamic state in here. Okay, so graphics pipeline. So let me see what is a graphics. Oh, this is a wrong place to look for this kind of stuff. Graphics pipeline, so it's available in Vulkan. Okay. This is a triangle. Do I already have pipeline? Yeah, I don't. Pipeline, graphics pipeline, there we go. And in here, graphics pipeline, I'm just starting the pipeline. I'm not quite sure why they're wrapping everything in arcs. Is it really necessary? It feels like it's really necessary for this specific example, but I mean, it is what it is. Maybe when you passing them to somewhere, it could be necessary. All right, so it's going to be arc new. Graphics start, and so vertex input single type. Okay, so this is the first thing we have in here. Then we're using vertex shader. Oh, interesting. So the main entry point. That's pretty cool. All right. The content of the vertex buffer describes a list of triangles. Okay, that makes sense. That makes sense so far. Viewport dynamics is irrelevant. Use a resizable viewport set to draw over the entire window. Sure. Fragment shader, C fragment shader. We have to indicate that's interesting. So, oh shit. Are these like different phases of the pipeline? That's actually a pretty interesting way of doing that. Huh. Okay. So render pass, and we're even cloning this entire thing. Okay, so then we're building it with the device, and then we're unwrapping this entire thing. And finally, we have everything we wanted to have in our entire life. And I'm pretty sure pipeline is not printable, right? So we can just print pipeline and make sure that it's working. Subpass. We don't have a subpass. Where subpass is available? Subpass. So it is available in a frame buffer. So let me quickly grab that. So this is where it is available. I wish my mouse was a little bit more like this. A little bit more like this. There we go. Okay, so what do we have in here? Given pipeline, consider type on the station needed. I have no idea. Cannot infer type V. Okay. How does it work in here then? I guess it works in there because we use pipelines somewhere down below, but apart from that, I don't see like why it wouldn't compile properly, but it does compile, I suppose. Maybe I'm gonna just you know, comment out pipeline, because right now it cannot infer the type of pipeline. All right. All right. Cool. So then triangle. So then we need to create a dynamic state. Dynamic viewports allow us to recreate just the viewport when the window resized. Otherwise, we would have to recreate the whole pipeline. Okay, makes sense, I guess. Dynamic state is available in Vulkan command buffer state, so we have to import this thing from here. Yes, so I'm gonna just put it in here. So now we have a dynamic state. So it's gonna be dynamic state. And this is the dynamic state that we have, so filled with a bunch of nonce. Alright, so can I now print it to indicate that it's actually the thing that I think it is? I'm a little bit hungry, not gonna lie. Okay, so I forgot to put a semicolon in there. I think that's what I forgot to do. This isn't a convent. Why is it filled with nuns? Okay, so let's continue. Windows side dependent setup. Oh, okay. I think, yeah, so they extracted this shit into a separate function. This method is called once during initialization, then again whenever the window is resized. Yeah, so we need to resize the window. Here we accept images, which is swap chain images for the window, render pass, and dynamic state. And I guess we're just updating the viewport. You know how in OpenGL you just do GL viewport? So in here you have to do this kind of stuff explicitly, and also returns you a bunch of frame buffers and whatnot, but yeah. So let me see, so it's a window resize. So you just take the frame buffers, and every time something resized we have to recall this entire thing. Okay. So you know what I want to do? I want to make a small break. I want to pee. So Rust makes me wanna pee really badly. You guys want to listen to some music? What music do you guys want to listen to? How about some country cake code? Hell yeah, bro. Okay. So let me see. Is it playing? Doesn't sound very country to me. Alright, let's make some break, and you guys have fun. Hey yo, what's up everyone? How everyone is doing? I'm back to bed. The arena. Let me see. So we need this function, which basically is called when the window is resized. So window size depend setup, and in here we accept images. Right, so which is a slice of arcs of swap chain images for a specific window. I guess that's what it means, right? It's a slice of arcs of swap chain images for a specific window. And arcs is basically reference counter, right? So reference counter. All right, so and then we're gonna accept the render path, arc render path. You know, it feels really strange. Like, is arc really needed in here? Like, we're not doing anything super sophisticated. Like in I don't know if it's really needed. Dynamic state, mute. Dynamic state. So maybe the next thing, once I make it work, if I ever make it work on today's stream, because we're already finishing the 3rd hour of the stream. We're almost finished the 3rd hour of the stream, and we don't have anything on the screen yet. So if I ever finish, I'm gonna try to get rid of the arcs, but maybe arcs are needed because the library itself accepts a lot of arcs. So, but so far it feels like I'm not sure if it's really needed. Like arcs, are they really needed here? But yeah, so it's gonna be arc. Frame buffer abstract, frame buffer ups. That's not fragment, but it's a frame buffer abstract. So, and also it implements send and sync. So this is the thing that has to be implemented in here. And can I in here return just whatever? So can I return vec empty? just to see is if it's compiled or not. Vulkan is weird. Yeah, I already noticed. That it's a little bit weird. So we don't have a swap chain image. So it is available in Vulkan here. So if I do something like this, can I then select this entire thing? I'm not using any mouse, by the way. So that's actually pretty cool. I just copy pasted this entire stuff without using any mouse. That's cool. Because technically, right, you can do something like swap chain, right, and then press shift and right and continue selecting, and then you press Ctrl C and just copy paste this text, and that is without using any special plugins for the browser. Huh. Okay. Who needs mouse anyway? You know what I'm talking about? All right. Copy paste degree, yes. So does it compile? No. Should we compile now? So window. We don't have a window. So maybe we have to do something like this. But the window could be, yeah. The value of window might be coming from here. Huh. And look, I'm selecting this entire thing like that. Boom. And I can just go here and just boom. Who needs mouse? My god. I'm a copy paste master. I copy paste from Stack Overflow so many times I didn't even need a mouse for that anymore. That's how many times I did that. That's absolutely epic. So we don't have a render pass for some reason, which is really interesting. Render pass. Do we have a render pass? I think we do have it. Vulkan. I can actually select by words. Because if you press Shift Control and left and right, you can select and unselect by words like that, which actually speeds up your selection strategy. So yeah, just a second. And then boom, 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 and then you copy paste it, and yeah, so you can actually improve your stats on copy pasting quite easily. So the frame buffer, we already have a frame buffer in there, so I can probably put this thing somewhere here, right? So something like that, and there we go. Absolutely goddamn fucking amazing, mate. Holy shit. Frame buffer abstract. What about this one? And there we go. So it's going to be Vulkan, and boom, boom, boom. And to be fair, I'm pretty sure we already have frame buffer in here, right? So that means I can just put this entire thing in here, and there we go. So that should compile. Fuck, it didn't compile. Excuse me. Render pass. It doesn't like my render pass situation for some reason. So if I take a look at that, so it has a render pass. Right, but when I try to compile this entire thing, it complains that expected one type argument. Maybe it expected for this render pass. Let me see. Render pass is from render pass, but in here, render pass. Oh, I see. So it is in fact from render pass. Render pass. Yeah. Okay, so maybe I have to do it like that. Oh shit, and all these things are from different places. Okay. All of them are for different places. So apparently Vulkan has several packages that contain types with the same name. And it's all of that is within a single library. But maybe it has something to do with Vulkan specifically. Maybe Vulkan just forces you to have the same names in different packages, right? So maybe there's a frame buffer as a concept on its own, and frame buffer as a concept in the context of render pass. You know, it do be like that sometimes. So software development, naming is hard. Okay, we all know that naming is hard. So yeah. Let's continue. So maybe it will compile. Finally, could not find render pass in Vulkan. Oh no. Oh no. Oh no. Is that a separate package? Okay, so it's probably a separate package. Let's try to find out. Render. So we have a Vulkan shaders. No. That's very strange. Toml. So I think I already import everything that is needed in here, so I don't think so. Could it be that the version differs in here? Could it be that the version differs? It could be the case, actually. It could be actually the case. Because they're using their own thing, but in my case. Render pass. And what does it say? It says that could not find render pass in Vulkan and used to import graphics part. So let me go there. So maybe it's not in Vulkan. So it says the SRC. Yeah, here's the render pass. Here it is. Here it fucking is. But now, let's try to do the following thing. I'm gonna go to the release tags. So this is the release that we're using, right? This is the release that we're using. And in here, I'm gonna go to the Vulkan, and then to here. And do I have a render pass? No, I didn't have a render pass. And I'm using the latest stable Vulkan, and the examples in the master depend on the features that are not released yet. Okay. If I understand correctly, of course. So I'm going to go to version 0.22, the one that I'm using, right? And I'm going to go into the examples, and let's find a triangle there. And hopefully it does have a triangle in there, right? And if you take a look carefully, render pass. Okay, so it doesn't import anything from the render pass. Oh, and in here, instead of depending on a type called render pass, it depends on interface called render pass abstract plus send plus sing and so on and so forth. You see? So okay, so yeah, this is actually pretty cool. Yeah, so the example still exists. Is that it's just like for the version of Vulkan that I'm using, it has to be slightly different. So the thing is, I'm not really sure how many changes they introduced into the new example. So the thing I'm gonna do now, I'm gonna grab this thing and put it on my hard drive. Right, I'm gonna just download it, and then I'm gonna download the version from the master and make a div between them, and I'm gonna make sure that they didn't introduce something like very, very special and didn't rewrite the example completely. I just want to see that the differences are in the render pass situation so far. So it's not the end of the world, as you can see. So it's not the end of the world. We actually caught it pretty early on, which is quite cool. I'm a little bit tired already, but I mean, yeah. Okay, so here is the stuff. So I'm gonna just try to download this entire thing. This is going to be wget, and I'm going to save it to triangle V0220RS. So here is that. I think I made accidentally a couple of changes to this example from the master, so I'm going to actually re-download the master example. So let me see how I can do that. So in here, I think I can just replace this entire stuff with the master, right? And I'm gonna have the master example. Then I'm gonna take it to raw. Gotcha, hyper. I'm taking it raw. So let me double check. Yes, it is a master. In fact, okay, and I'm gonna just do it like that. Can be O triangle master. Who needs dungeon master when you have a triangle master? My name is Van. I'm a master. I'm an artist. I'm a performance artist. All right. Anyway, I think I'm getting sidetracked. So I'm gonna do diff u starting from the previous version and to the master one, and let's actually save it to the file, because then I can okay. Do I want to open it? Do I want to disappoint myself? Okay. Oh, okay. So it's just like it's not that much. Actually, all right. The only changes that they made are to the render pass. This is literally the only changes. Very nice. Very, very nice. Not... Oh, and yeah, all of these things were before. Okay. Remember how I said that there was a situation that they have the same types in different sub packages? Well, that was not the case. They just moved them in the new release to a different sub package or module. So that's what happened. That's why in the example I saw them in one package, but they were moved in another one. So since we're using an older version, we're not using even that old of a version. We're using the one that is the latest stable. This is not release changes. Right. Since we're using the older version, we have to just use that one. Oh boy. Okay, I'm really glad that we caught that early on and it didn't go too much into like a rabbit hole, and the rabbit hole stopped around like right here. So yeah, okay. I think I need to make a cup of tea. So before I'm gonna go, yeah. So it's just like this is the only changes that we have to make in here. I'm super happy. All right. Does anyone have any questions? Does anyone have any questions? Valentin, what's up? How are you doing? How are you doing? Welcome. Thrash 5, what's up as well? Did you exercise today? I'm sorry. I'm really sorry. I'm a little bit tired already, so I'm streaming for 3 hours. Making cup of tea. Yes. Cup of yes. All right, so it's gonna be super quick. I'm gonna go to the kitchen and turn on the kettle, and I'm gonna be back. So if you have any questions, prepare them, and maybe I'm gonna answer them. Alrighty. already took 2 attempts on getting into Vulkan, but both time I couldn't handle it because of how tedious it was and because I didn't have any real application. Well, I'm just following the tutorials. I'm not even doing anything special, so yeah. Let's see how it goes. So I just ended up drawing some basic stuff and moved on with my boring PHP life. You may want to start with OpenGL actually. OpenGL is a little bit simpler in that regard. And I would probably even recommend for people to start with OpenGL because in OpenGL you can at least learn some of the concepts that could be useful in Vulkan. Right, because for example, I know a little bit of OpenGL and I started to use Vulkan and I'm like, oh, okay, so I know some of these concepts already, even though I don't know Vulkan. And knowing OpenGL definitely helped, and it's just like, yeah. Does anyone have any questions, maybe? I'm just waiting for my kettle to... Okay, so main or ass? More like main my ass. Frame buffer. So this has to be a frame buffer. And instead of this thing, we just have to put this thing in there. Vulkan is a safe wraparound Vulkan. Yes, it is true. You can Google that. It's actually the first thing that pops up when you Google Rust Vulkan, and that's literally the only reason why I chose it, because I was thinking, I think the time has come to stream Rust and Vulkan, and I just Googled Rust Vulkan, and this was the first link, and this is how we got here. So, nothing much to say. This is how I make all of my technical decisions. People keep talking about something called ash, but Rust Vulkan. Do you see ash anywhere in here? Pfft, irrelevant. Irrelevant. Okay, so I'm so sorry. This is a joke, by the way. I'm just joking, okay? I'm only learning Vulkan, and just give me some time. I just want to play around with the concepts, and maybe I will look into Ash a little bit. Don't take me too seriously, okay? Sometimes people take me way too serious, so I recommend to not take me too serious. I'm just shitposting on the internet. Come on. I'm just a memer, and I meme my life away. All right. I'm just a memer. So what do we have in here? Does it even build? Let me see if I can even build this entire thing. All right. So render pass abstract. Yeah. Okay, it's in the frame buffer. Vulkan. Sorry. So it's all available in here. So let's try to do that. So it didn't pause? Is this gonna fucking compile? Is this gonna fucking compile, mate? Holy fucking shit, mate. Alright, so this should fucking compile. Can you believe that? Okay, so it's gonna be V22, and we're gonna follow this tutorial now, the one for 022. The one for 022, the one for 022. So render pass, we create the render pass pipeline. It was very difficult to create the pipeline, so we're not creating it yet. So, and the next thing we need to do after the dynamic state, well, we need to implement this function first. Yes. So what do we do? We take images, right, and we take the first one, and we take its dimensions. Let dimensions is going to be something like this. And then we need to construct something called viewport, and I wonder if viewport is a concept of Vulkan. Yes, it kind of is. Yeah, so it is sort of a concept of Vulkan. So do we have a pipeline? So we already have a pipeline in there, but we don't have a pipeline viewport. So probably we'll have to do it like this. Pipeline viewport. Okay, so we need to construct a new viewport if the window got resized. So it's going to be viewport, viewport. So the origin is going to start at 0, 0. Then dimensions. This is very strange. Can you just like map this entire thing into, maybe not, maybe you have to reconstruct it, but it would be kind of cool if you could just take the dimensions and map them like this, if you know what I mean, and just use dimensions directly in here. I wonder if that will work, but so let's not experiment right now. Let's actually make it compile first, and then we may try to improve it. Dimensions is going to 0 as f32, dimensions 1 as f32. Okay, so after that we have a depth range, and I suppose this is a range of z, right, for depth and stuff, and it's going to be a range from 0 to 1. I don't know why it is important to customize this kind of stuff, but okay. So, and then we set viewports like this, and after that, is viewport even needed? So do we even use view? Okay, that's really interesting. So we create a viewport once just to set it in here like that, but couldn't we set it directly? Why does it have to be like a separate thing in here? So this is, I think this is another thing that could be maybe inlined at least. So then we take dynamic state, viewports equals sum vec viewport, actually a single viewport. Then we're taking the images, we're mapping each individual image, we create a new image view, and we recreate all of these things in there. All right. Oh, I see. Okay. So if the... Holy shit! I think I'm understanding. So if the size of the window changed, we literally have to take all of our images of the swap chain and create them from scratch with the new size. Explicitly. Okay. That is very interesting, like literal manually. So you have an array of these swap chain images, something changed, yeah, remove the previous ones, which is probably done by automatic memory management of Arc or something like that, and create the new ones. Yes, I guess that's how we do. I wonder if you can just create big images for swap chain, like very, very big. And when the window size changes, you just take the sub range of this image, and you don't have to recreate things too much. So maybe you have like an upper limit of how big your window can be, so you don't spend too much time doing these kind of things. But it's just like a theoretical thing, right? You know what I'm talking about? because that's how I usually do when I program like in C, like when I make a grid-based game. And in a grid-based game, like window can resize, which will increase the size of the grid. I will just pre-allocate like a huge array, and so I don't have to resize the array or something like that. Just like I take a bigger subarray, and there's a limit on how big you can make a window, so you don't spend too much time. But I mean, it's like, it's whatever. It's just like a stylistic thing, more of a. All right. Very interesting. I suppose OpenGL just does all of that for you implicitly, right? But in Vulkan, you have to do everything explicitly. Do you guys like Vulkan so far? You guys think it's gonna be the future of game development? Whoa, oh, oh. Are we game yet? Are we game yet? Whoa. I'm sorry. Okay, so we take all of the images, and we are iterating through this entire stuff, and we're mapping all of that. So here's the image. So what I'm doing in here is image clone, right? And I take the image view and I create a new image view, right? Right, and then I create a completely new thing. Did I already create frame buffer before? Oh yeah, this is the first time I'm creating everything in here anyway, so yeah, that makes sense. All right, so frame buffer start render pass clone. So then I add the view, build the frame buffer, and it, on any of these things, I mean, you could probably do something like end then, but it's not going to be super convenient. I think this is a little bit more convenient to do like that. So after that, we're going to wrap it into an arc for reference counting capabilities, right? And then do it as this: frame buffer abstract plus send plus sync, and maybe I'm going to actually format the buffer, maybe not. Yeah. I'm falling asleep, chat. Okay, and after that, I need to collect that into a vector. Oh my god, Emacs, there we go. Alright, so that should kind of do the trick, I think. I think that should kind of do the trick, but it does not compile because we don't have an image view. Do we have an image view available in here? So I'm gonna take that. I'm gonna put it in here. Is it gonna compile now? For the semicolon. And I think this seems to be compiling. This seems to be compiled so far. Let's try to call this function now, right? So this is gonna be a triangle. This is gonna be a triangle, and where do we call this function? So we call it in the event loop and when we initialize the frame buffers, right? When we are initializing the frame buffers. So we're initializing the frame buffers after we created the dynamic state. Here's the dynamic state, so that makes sense. All right, so let's mute frame buffers, right? Then we take the window size dependent setup, so the function that we just created, we're providing the images, render pass clone, and then mutable dynamic state. Immutable dynamic state. So that should work, and I can try to maybe print these frame buffers, just in case, just to see what's gonna happen. Did I save it? I think I saved everything, so it doesn't compile. Let's find out why. This is because this thing is not printable. Okay, so it's not printable. There's nothing much you can do here anyway. But apart from that, I think it's compiling. What type is images? I think it's an array of images. Oh, you can see the type in here. Here's the type. It's a slice, a sequence essentially of arcs of swap chain images over a specific window. That's what it is. Hopefully that helps you. Okay, so the next thing is going to be a triangle, and yeah. So the render path we created above only describes the layout of the frame buffers before we can blah blah blah. Initialization is finally finished. In some situations, the swap chain will become invalid by itself. This includes, for example, when the window is resized. As the images of the swap chain will no longer match the windows, or on Android when the application went to the background and goes back to the foreground. In these situations, acquiring a swap chain image or presenting it will return an error. Rendering to an image of that swap chain will not produce any error, but may or may not work. To continue rendering, we need to recreate the swap chain by creating a new swap chain. Here, we remember that we need to do this for the next loop iteration. Okay, that's very interesting. So there's a special variable where we keep track that we need to recreate the swap chain, right? And swap chain may get invalidated at any point. Okay. In the loop below, we're going to submit commands to the GPU. Submitting a command produces an object that implements the GPU future trait, which holds the resources for as long as they are in use by the GPU. Destroying the GPU future blocks until the GPU is finished executing it. In order to avoid that, we store the submission of the previous frame here. All right, so we use something called sync, previous frame end. So is sync basically std sync? Is it std sync? I think it is. Oh yeah, I see sync. Yeah, it's a Vulkan sync. All right, it's a Vulkan sync. Let's put it in here. Sync. So previous frame end. Let's mute previous frame end some sync now, not new, now, device clone, and we make it boxed, and there we go. So this is needed for some reason. Okay, so then so this is the entire event loop. Okay, this is essentially an entire event loop. Alrighty. Event loop run move event control flow and then we do this entire thing. All right, match event. Right, so we're just looking for very specific events and stuff like that. Oh, it's actually kind of similar to event loop that I developed for RCUI thingy, remember? Yeah. Is that how it's called? Yeah. So I was developing like I guess it's a pretty natural idea to have UI like that. Event loop, I mean. Yeah. No, it's actually kind of different. Yeah, it's kind of different. I think it was my previous situation. My previous situation kind of looked like that. But yeah, so we can set control flow exit, and that means it will basically exit on the next iteration of event loop. To be fair, I'm not a big fan of these like event loops where you provide a lambda and stuff like that. I kind of prefer like explicitly having my loop and have functions that poll events. I think like it gives you a little bit more control over the situation, but I mean, so the library forces this kind of style on us anyway. So redraw event cleared, and Okay, so that's a huge event handling, not gonna lie. It's a pretty huge, but there's a lot of comments here as well, so I don't think it's that bad. Also, by the way, I wanted to make some changes in here. So I wanted to try to inline the viewport because it feels like maybe you could just inline it instead. I want to try that and just see if it's gonna work. So I'm gonna comment out this entire stuff. And I'm gonna format maybe Rust format buffer and something. Yeah, this is a use Rust format buffer, and I think it formatted everything properly. And there we go. What file are you referencing? The textual one, the text file. Okay, so we're also using now future, not method not found. Maybe this is because we have to import some of these things. Okay. Maybe because we have to import them. So yeah, maybe it's gonna be GPU future. Can I get the text file? Is it public? Oh, you probably mean, okay, so I see what you're trying to say. I'm following this file from vulkan.rs. So yeah, so maybe I need to update my project comments. Okay, so today we're learning following the triangle tutorial, and I'm gonna put this thing in here. So yeah, now every time somebody asks that, you can do a project command and it will give you a link to this file. Vulkan. I want to also kind of update my title. So what do you guys think about learning Vulkan with Rust first triangle? Is that a good title? Yeah, I think it's a pretty good title, so let's actually do that. 9 p.m. You're talking... Oh yeah, we still have a little bit of sun, if that's what you're talking about. Maybe. Alright, so... And we don't have like a summertime saving thingy anymore. I think we discussed that, yeah. Thank you, Mr. Putin. Very cool. Very, very cool. Okay, so price the sun. So this is boxed, and I wonder what I forgot to... Yeah. So we also have a sync. Sync. Yeah, so maybe I need to import these things. Oh yeah, I guess that was that's what was needed. Okay, now we're talking. Oh yeah, so no, we don't have any other power matches. So in an example, how do we handle the events? So yeah, the default value for a known event is just do nothing. Okay. Let's just do nothing. So it's gonna be something like this. And I also want to format the buffer. Okay. So we try to compile this entire thing. It should compile, hopefully. Is Vulkan pain? Oh shit! We created a window after 3.5 hours. 3 hours, 25 minutes. We created a window. You can't close it, by the way. You can't close it because we don't handle the close event, right? We don't handle the close event. But we managed to create a window with a Vulkan context. Isn't that amazing? Oh boy. Oh boy. Okay, so is it Vulkan? I can do kill all Vulkan. And I think it died. Yeah, I think it died. It got terminated. It got terminated. Yeah, stream is over. Yeah, exactly. Because not yet. Stream is not over. It's not over till it's over. Okay. I want to see some triangle action today, to be fair. I want to see some triangle action. So let's try to handle the close event. So it's going to be window event. And if the event is window event close requested, right, and we ignore everything else, in that particular case, we just take the control flow and set it to control flow exit. That's what we do essentially. That's what we do. So let's see if now we can close the window. We can't even compile that. Okay. So all of that stuff, event and everything, yeah. I guess we need to have it in here as well. Oh shit. Let's put it here. Fuck. Triangle. Init. So we already have that. All right, so we have to wait, and I think it should. It takes extra time. Okay, so finally it works. Now, can I close it? I can close it. So we do handle the close event. Cool. We do handle close event. So what's going to be the next event that we need to close to handle? What's going to be the next event? The next one, I suppose, is resize, right? So in case of a resize, we have to... holy fucking shit. So the redraw event cleared is 139 lines. Okay. So, all right. So what do we have in here? Event, window, event, event, window, event, resized. Resized. So recreate swap chain. So basically a reminder that we need to recreate the swap chain. So and recreating the swap chain is going to be done in this particular event. Cool. We still, like, I think I still have some piece of code commented out. Yeah, I still don't need this pipeline. That's what's weird about it. Like, I still don't need it. Okay, so let's go, and we need to implement the last event. We just need to handle the last event, right? This one, actually this one, yes. Redraw events cleared, and we're gonna have something on the screen, hopefully. I don't know yet, but we'll see. We'll see. I'm a little bit tired. Like, it's like, oh, holy shit. But I'm almost done. I will also recreate the whole thing in here. So redraw events cleared. Oh boy. So I suppose here we're just doing this thing, right? Okay, let me open triangle here. It is important to call this function from time to time, otherwise resources will keep accumulating and you will eventually reach an out-of-memory error. Calling this function pulls various fences in order to determine what the GPU has already processed and frees the resources that are no longer needed. Garbage, literally garbage collector. Okay. I'm not even commenting on any of this, right? I'm not even commenting because like it's pointless. All right. Whenever the window resizes, we need to recreate everything dependent on the window size. In this example, that includes the swap chain, the frame buffers, and the dynamic state viewport. All right, so recreate swap chain. Okay. So we take the surface window inner size, and here we have the dimensions. Right, here are the dimensions. And we need to recreate the swap chain with the dimensions, but that can fail actually. Right, this error tends to happen when the user is... Manually restarting the window, simply restarting the loop is the easiest way to fix this. Okay, cool. So we're gonna do swap chain, recreate with dimensions, and we provide the dimensions that we just got from the window. Okay, so and if it successfully happened, here it is. Here is the new swap chain, and if we got something like swap chain creation error, which is unsupported dimensions, we just go to the next iteration of event loop. If we got something else, we'll need to panic. Failed to recreate swap chain because of this situation. There we go. Because of this situation. Very cool. And so then I'm gonna do new swap chain, new images, and here is everything new in here. There we go. And then yeah, we have an old swap chain, and we need to assign new swap chain to the old one, right, like this. So then we need to recreate the frame buffers, window size dependent setup. We provide the new images, then render paths, we need to clone it yet again. I suppose when I do clone on an arc, what I'm essentially doing, I'm not cloning the object, but I'm rather cloning the reference counting pointer, and cloning will actually increment the reference count. This is probably why we have a lot of clones in here. So let me check it out. So what about arc? Let me see, because I want to see. So invoking clone on arc produces a new arc instance which points to the same location on the heap as the source. Okay, I actually, yeah. This is why the, yeah, remember how since the beginning of this stream I was like, why they keep cloning this entire shit? Why they keep cloning? They're not cloning the objects, they're cloning arcs, and cloning the arc just increments the reference counter. But I'm still wondering, can we just get rid of arcs altogether? Like, we're not having like a very huge like hierarchy structure system, like where different systems may own the same resource. We actually have like a single like namespace where we could probably get rid of all of the arcs or something. I just don't understand why do we use it in here. I think it feels like a little bit of an overkill, but I'm not sure yet. So I just want to finish the example until it actually works, and only then, once we have a working example, we can try to do different things and see if they're possible or not. Maybe the library actually limits like what kind of stuff we can do. Anyway, okay, so now at least it makes sense. All right. So, okay, here's the frame buffers and all the shit. Then mute. dynamic state, and so we managed to successfully recreate swap chain, I suppose. Swap chain and make it equal to false. So yesu, kawaii Vulkan desu. Yeah, we can try to run this game now, this program now. Swap chain creation error. Swap chain creation error, and I suppose I might as well. Well, all right. Swap chain. We have an image. Let's put swap chain creation error. There we go. Swap chain creation error. Is it gonna work now? No swap chain creation error. Okay. Oh, I'm an idiot. Just a second. Yeah, because it's a regular swap chain. I'm sorry. Swap chain. Yeah. It should be somewhere here. Yesu. Kawaii Vulkan desu, mate. Okay. So now, every time we resize here, we're actually recreating the swap chain, but we have no way to confirm that it's actually the case. Because we don't have any side effects, visible at least visible side effects. All right, so let's continue developing this entire thing. Triangle, recreate swap chain, and what do we have? Before we can draw on the output, we have to acquire an image from the swap chain. If no image is available, which happens if you submit draw commands too quickly, then the function will block. This operation returns an index of the image that we are allowed to draw upon. This function can block if no image is available. The parameter is on the optional timeout, after which the function call will return an error. Okay, so we have a swap chain, acquire next image in a swap chain. Okay, that actually makes sense. So we need to acquire the image. Oh, that's pretty cool. So swap chain as an object, you have to acquire the new image, and oh my god, okay, that makes sense, I suppose. So we have image numbers, suboptimal, acquire future, and it's even the future, of course. Acquire next image can be successful, but suboptimal. This means that this swap chain image will still work, but it may not display correctly. With some drivers, this can be when the window resizes, but it may not cause the swap chain to become out of the date. Oh, okay. You have to handle even these kind of situations. Okay, interesting, very interesting. All right, so let's do swap chain, acquire next image. So we take the swap chain and we clone it. Yeah, I suppose I can see now. The library itself requires you to have arc. So that's why you won't be even able to do anything about that. Like you won't be able to get rid of the arc. Yeah. So this, yeah, as you can see, the library itself like forces arc upon you. So it's probably not even possible to get rid of it. All right, so I guess it is what it is. I mean, if the library wants us to use it, we can use it. So we acquire it, and when we acquire it, we also have a timeout, right? So yeah, we can put it on a timeout, and then when we match it, right, we can either get the image from the swap chain, or it could be an acquire error. Acquire error out of date. Out of date. So in that case, we have to recreate swap chain and go to the next one. All right. So and then it's going to be error. Panic. Failed to acquire next image. So it means we failed because of an unknown reason. So out of date is a well-known reason of not being able to acquire it, but anything else is a known one. So it's kind of important to fail. So let me see image num suboptimal, and acquire future. Okay, so let's do it like this. So after we acquired everything, if it's suboptimal, we just have to not forget to recreate the swap chain, right? It's kind of interesting that the API itself gives you this kind of information and allows you to handle this kind of information. It's actually pretty cool. It is in fact very low level. Okay. So, and if we got something suboptimal, right? If we got something suboptimal, we need to mark it as recreate swap chain. Recreate swap chain. Okay. So let me try to see if this still compiles or not. All right. So let's go. Yeah, swap chain has to be like imported properly. Vulkan swap chain. Surging clown. All right. So, okay, this seems to be all right. It's actually pretty cool that Surging Clown is a combination of Surging Flushed and Surging Smug, I think. Right, so the eyes are from Surging Flushed, but the mouth, I think it's from the Surging Smug. Right, if you check them, something like Smug. Yeah, it's kind of, yeah, but it's a little bit down. It's put a little bit down to leave some place for the nose. Right, so everything seems to be working. Everything seems to be twerking. Oh, and I cannot close it anymore. That is very interesting. Why can't I close it anymore? I'm trying to close it and it doesn't close. But I can at least interact. Okay, so All right, let's continue. So this is going to be something like this. Image num. All right, so it's going to be image num suboptimal. And we need to start clearing the things, right? Clear values. So, so it's gonna be 0. I think I'm gonna clear with maybe black color for now. There we go. Clear values. Specify the color to clear the frame buffer width. For example, blue. In order to draw, we have to build a command buffer. The command buffer object holds the list of the commands that are going to be executed. Building a command buffer is an expensive operation, usually a few hundred microseconds, but is known to be a hot path in the driver and is expected to be optimized. Note that we have to pass a queue family when we create a command buffer. The command buffer will only be executed on that given queue family. Okay. So auto command buffer, build the primary one, submit. Okay. Alrighty. So let's create the auto command buffer builder, whatever the fuck it is. Okay. Let mute builder, and we don't even use clear. Where do you use clear values? You use clear values like down below. Oh, okay, I see. All right, so it's going to be that auto command buffer builder primary one time submit. All right, so device clone view family, and let's just unwrap this entire shit. Okay, so that looks okay. So let's see if this compiles. I'm not gonna just I think I'm not gonna right away compile run it. Let's just try to build it, because running does not necessarily work. Auto command buffer builder. Oh shit. So so command buffer. Do I already have a command? Yeah, I do have a command buffer. Auto command buffer in here. So it's gonna put it in here. Shit. Oh fuck. Oh shit. Oh fuck. Okay, so is it gonna build now? Hopefully it's gonna build now. So here's the error, and let me take a look. So it cannot use that yet. So let's comment it out now. It's not usable right now, but we'll see. We'll see. Okay. So here's the builder and begin render pass. Okay. Before we can draw, we have to enter a render path. There are two methods to do this: draw inline and draw secondary. The latter is a bit more advanced and is not covered here. The third parameter builds the list of values to clear the attachment with. The API is similar to the list of attachments when building the frame buffers, except that only the attachment that use load clear appear in this list. Cool, makes sense. That makes absolute sense. Okay, let me see. So it's gonna be builder and begin render pass. And it's gonna be frame buffer image num. Oh yeah. So when we get an image, we get that from acquiring an image. Yeah. So it's actually pretty cool. So swap chain acquires an image, right? It acquires. God damn it, you. All right. So it acquires an image and it returns us an index of the image in a swap chain. Right, and then we can use that image in the array of frame buffers. Okay, that's pretty cool. So, and of course we clone it, basically acquiring it with reference counts and whatnot. So then sub pass contents. I don't know how to do that, but yeah, okay. So all right, and here we're gonna do unwrap. We're now inside. Oh fuck! Oh shit! Oh fuck! Oh shit! We're now inside the first subpass of the render pass. We add a draw command. The last two parameters contain the list of the resources to pass to the shader. Since we used an empty pipeline object, the object have to be that. Makes sense. Okay. So we're gonna do draw, and then it's gonna be pipe line. So we take the pipe. Oh, okay. So this is where it becomes very interesting. So I couldn't compile the pipeline because I didn't have an information to infer the type of the pipeline. So I had to defer implementation of the pipeline up until this moment. Remember how somewhere in the middle of the stream I couldn't compile this thing? So yeah, and I just commented it out because it is needed here, and this is the place where it gets enough context and enough information to defer the type. So it's some sort of like a non-linear tutorial, right? Sometimes you just need to not compile some things, and only then they make sense. All right. right, so okay, so this is going to be that, and then we provide the dynamic state, and then we take the vertex buffer, right? So we take the vertex buffer, and then we clone it, and the rest of this stuff is not important as the comment set. So we're gonna just put it like this. So after that, we're gonna do unwrap. Okay. So here's that, and yeah. So this is the last thing that we did in the builder, right? So this seems to be the last thing. So let me try to compile it now, and it should fail, right? It should fail because of this kind of stuff. So subpass content. All right. Let me see. It's a Vulcano. Okay. So let me put it like here, like that. Command buffer, and this is where we have to put this entire thing, right? So this is where it is. And the last thing, we don't have a pipeline clone. And this is where we have to uncomment this entire thing to understand. And it still doesn't have enough information to do this shit. Interesting. Oh, some sort of a trait is not satisfied. Okay, the trait bound single buffer definition. Maybe we just have to have this. The type actually contains a template. Okay. We need to indicate that the layout of the vertices. The type actually contains a template character, blah blah blah. But it's only mentioned in here. So it's only mentioned in here, so I'm not quite sure where we can get that. So it is available somewhere here. And maybe I can basically import it from there, right? Oh wait, maybe I wasn't looking at the triangle single. Nah, it's still that. So it's gonna be pipeline. Pipeline vertex. Yeah. So maybe that's what I have to import here, but it's kind of strange that I have to import that explicitly. Right? You know what I mean? Still not a thing. Still not a thing. Okay. Draw. So it feels like maybe I just retyped the pipeline thing incorrectly. So let me see. Maybe I missed something in here. Okay, so it feels like I might have actually missed something. Right, so let me go back. And maybe I'm gonna just try to copy paste this entire thing now. Now I'm already copy pasting code, right? So let's remove all of the comments. And maybe then it will be more obvious that I missed something. Maybe I missed some calls. That could be the thing. Okay, so we have a vertex input, then that, triangle list, viewport dynamic scissors, fragment shader, render pass, okay, build, unwrap, and yeah, it's literally the same, isn't it? It's literally the same thing, almost. Okay, well, I mean, I can try to comment it out, but it's still... nah, still doesn't work. Okay, maybe it has something to do. Maybe it's not about single buffer, but it's about like CPU accessible buffer. Did you put clone on your vertex? I remember you did default and debug. Ah. Holy shit. How did you notice that? Okay, so no, it didn't really help. But that's a good point. That's a good point. So vertex, so yeah, default clone and something something. Well, I mean, besides the point, how did you notice that? Because I completely forgot about it, like, yeah, but you do remember. How do you do that every time? Holy shit. You're so good at programming, way better than me. Alright, so there's something wrong in here. Maybe I just have to continue. Okay, let's just try to continue. Maybe then later. It feels like I just need to import some of the things, like in terms of imports. You know what I mean? Because some of the imports like are required here. I'm pretty sure if I just take all of my imports, right, and replace them with the imports from the tutorial, this shit will just work. I'm pretty fucking sure. It's just something about the imports. Yeah, and this one, something like this. No, it's not that. Oh shit. That is so interesting. Okay, okay. So that maybe there's a hope. So maybe we still don't have enough information to derive the types. You know what I'm talking about? Maybe we still don't have enough information. I don't know. Let's just continue. Let's just keep believing that at the end it will just work magically. And everyone is, well, I mean, this should be enough information already. Do we use pipeline anywhere else? Pipeline. Okay. So this pipeline is used. There's too much pipeline here, and that's the only place where it's used. Seriously, that's the last place. But maybe because of the builder, it's gonna have like a different type and something. Oh my god, I don't even know. I don't even know. It's something specifically about the pipeline. Yeah. Builder. Okay, so this is the command buffer. All right. So maybe we're gonna do something like this. Okay, still doesn't do it. Still doesn't do it. All right, so okay, let's. I really don't want to continue until I fix it because it doesn't make any sense. This is really bullshit. Like holy shit. What's pipeline? It's literally the same. It's literally the same. It's not from the imports. It's not from the imports. I'm already streaming for 4 hours, by the way. Does anyone have any questions? Maybe I need to make a small break. Any questions? Ask me something, please, because my brain is just too caught up on this bullshit. So just ask me something, please. I'll probably need to make another cup of tea. Okay, whatever. Do you like toasts? No. Is P stored in bowls? Yes. Okay, thank you for your questions. Really appreciate them. The P is stored in shaders. That's for sure. Thank you for the questions. Really appreciate them. They helped me a lot. Alright. We're almost there. But I still don't quite understand. Maybe we need to Google up something. So maybe I need to read into the error. So the following implementations were found. Trade-bound single buffer is not satisfied. Single buffer definition is not implemented. For vertex source. Okay. So, and it happens somewhere. Vertex buffer. Oh, the problem is actually with this thing. Okay. Do you see the difference? Chat, do you see the difference? I swear to God. I'm afraid to go there and press a single D. And then people get mad at me when I complain about this language. Like, they legit get mad at me when I complain about it. Is it like I'm being unfair, I'm just doing something wrong, I didn't read documentation, blah, 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 all of these things. And that's why I just not say anything anymore, right? Because I just program this and I just show you what it is, and I'm not saying anything. I'm just showing you. Because saying anything is pointless. I'm just showing you. So I just let the code speak for itself. I'm not saying anything. Okay, so let's give it a try. Let's give it a try. Did it compile? Oh, it compiled. Why he got mad again? I'm not mad. This is a good language. What are you guys talking about? It's perfect, like in all the ways. Like, I absolutely love it. I think it's very, very good. Like, yeah. It is very, very good language. Why would I be mad at it? I'm really enjoying my time right now. Like, I really enjoy programming it. Okay, so everything seems to be compiling, and yeah, let's see. Okay. So then we do this previous frame thingy. So it's gonna be take. And to be fair, I don't know how to work with features. So then acquire future, and I wonder where acquire future comes from. So it could be actually. Oh yeah, okay. So we acquired the image from the swap chain, and that gives us the future, and okay. Okay, I think that makes sense. Then execute. So provide the queue. Like, Okay, so now I understand why we clone these things all the time, but it still messes up with my brain because I got used to when you clone this thing, you create a copy of an object, right? So, oh shit! Oh fuck! Now, I was always thinking, how do you fucking implement reference counting in Rust? How do you fucking do reference counting in Rust where you have this borrow checker model and stuff like that, where like, how can you make a reference to the same thing from different places? Like borrow checker just won't allow you to do that. It's a hack! It's a hack, so they created arc object that treats borrow checker into thinking that you're cloning an object, but in fact you're not. Oh my god! Holy fuck, this is such a good link. This is genius. This is such a cool idea. I really like it. Oh. The more I explore this language, the more I actually start. This is absolutely genius. Oh my god. That is so cool. This is very, very cool. It's just like, yeah. Like, how can we have reference counter in a language that, on a semantic level, fundamentally does not allow us to have reference counting? Well, we just trick it into thinking that we're cloning the objects. That is so cool. Okay. So, it's gonna be unwrap. Okay, so this is the future, and then swap chain present. Okay. Then swap chain present q clone swap chain clone. It still messes up with my brain. God damn. It really messes up with my brain because I clone. Why do we making so many copies? Why do we make so many copies? We're not making copies. All right, so this is not copies. Signal, fence, and flush. Okay, so cool. Can we just try to build this entire thing? And yeah. Alrighty. All right, so after that we take a look at the future, and if it went okay, we just store it as a previous future. Okay. All right. Okay. Future. So what does it do? Does it do trick? I don't understand what you're trying to say. I'm sorry. How does it work? How does it do that? I think you're copying. It's the same way how shared pointer works. I think it's literally the same. When you're copying, you're not copying the object itself. You're copying the object that stores the pointer to that object plus a reference to the global state that increments like the value in a global table or something like that. I think it's literally like shared pointer or something. But there's also RC. I don't really know much about Rust, so I might not know that, but I think this is how it works. So there's arc, thread safes, and I think just RC is not thread safe, right? A single threaded. Okay, so they're pretty much the same, but the one is single threaded, another one is not single threaded. Okay. I think the ref count is stored alongside the inner object on the heap. The inner object on the heap. I see. So the lookup is O of 1, right? So essentially you know the pointer, and with O of 1 you can instantly look up the how many reference you have. Okay, so that makes sense. Maybe before the object or after the something like that. Yeah, okay, that makes sense. And also, you know, it's probably good for the cache, right? So you don't jump between some sort of table and the object itself. So I think the actual analog of shared pointer in C++ will be RC, right? It's like just a regular one, but with, yeah, but single threaded. Okay. Okay, Gum. Interesting. Shared pointer as atomic. Oh, okay, so that means our arc is literally the analog of shared pointer. Sure. Okay, so previous frame and some future boxed. There we go. Flushed, error, out of date. And if something like this happened, we recreate swap chain true. Yeah, that's probably what we need to do in here. Fail to flush future. I wonder if we may end up with a situation where this will be printed on each iteration of event loop and it's gonna actually absolutely destroy the output of the program. Fail to flush future. Chat, look! It's an ASCII version of Tsoding Clown, but on the side, 90 degrees. Sorry. Previous frame and some sync. Sorry. Okay. I guess that's it. That's the end of this entire stuff. And so this is roughly 326 lines of code. A code. We're just waiting for the compilation. All right, so we have a couple of warnings. Let me take a look. We don't have a render pass. Vulkan. Why did I call it Vulkan? Ah, it's a good look who suggested to call it like that. Vulkan. Vulkan. It's getting flushed. Okay. So what do we got? One more time. I just want to compile it without any warnings. I just want to compile it without any warnings. I just want to make sure that it compiles without any warnings. And we're going to try to run it for the first time. Try to witness the glory of the triangle. Or the glory of the black screen. Who knows? It just depends on what we're gonna see. So are you guys ready? We're gonna witness the triangle after, wait a second, 4 hours and 15 minutes. After 4 hours and 15 minutes of work, we're about to witness triangle, maybe for the first time. Are you ready? Holy fucking shit. Here it is. Here's the fucking triangle. Yes. Here it fucking is. Isn't that amazing? I think it's goddamn fucking amazing. I'm gonna fucking cry. It's so fucking beautiful. 4 hours of work. 4 hours of work. And finally, we've got a triangle. Now that's some achievement. Holy fucking shit. That's the future of software development. Right in front of you. You see? Absolutely beautiful. Astonishing. And that is available for everyone. Anyone can just download Vulkan and Rust and just make the same thing on their computer. And it's absolutely safe. It's absolutely safe. It's not gonna hurt anyone. Amazing. So can we actually make it rainbowish triangle? Kappa Pride triangle. We need to make it Kappa Pride triangle. So the easiest way to do it Kappa Pride triangle is actually pass color information along with the vertices, right? But I have no idea how to do that, so that's a huge problem. So I think we can try to do the this thing on the level of the shaders, right? So in GLSL, as far as I know, we have a thing called GL vertex ID, right? So that means we can distinguish between different vertices, right? Between different vertices on the level of a shader. So basically, I think we can have something like output somewhere here in the vertex shader. Let's actually put something like this. So it's going to be out vec4 vertex color, right? So, and then in here, we're going to have the input, right? We're going to have some sort of input as the vertex color, right? So what we're going to do in here, depending on the vertex ID, we're going to set the color either to, yeah, so essentially if it's 0, I want the color to be red. If it's 1, I want it to be green. If it's 2, I want it to be blue. So the easiest way to do that would be to probably create some sort of array, and we're using like the latest GLSL, like 4.5 something something. So that means we should have all of the perks of this GLSL, right? GLSL arrays. So how do I do arrays? So I just need an example on how to do arrays. Swizzling. I don't know what that word means, but I really like it for some reason. Arrays. So we have arrays. I guess I can just do it like that, I suppose. Yeah. Well, okay. Well, I mean, you can always just do ifs, but nobody likes ifs, right? So vec4 colors, and we're gonna have 3 of them, right? So we're gonna have 3 colors. And I keep forgetting how we initialize them. Like, it's so difficult to find any examples. Array initialization. It's like with the component reversed. Okay. It's just so difficult to, and doesn't make much sense. I remember having troubles. GLSL array initialization. Okay. So yeah, it's kind of like with these things, but if I have a vector, how do I do that? So it's probably going to be like vec this, and this is what I want to have here, right? So 0 has to be vec4 1 0 0 1. All right, so then it's gonna be like this, it's gonna be that, and this is gonna be another one. Right, so this is basically what I want to have. Is that the correct way of doing that? I don't know, maybe, who knows. And vertex color is going to be equal colors based on GL vertex ID. Right, so this is basically what we want to have in here. Essentially we're going to assign the output color to the vertex vertex color, and let's see what's going to happen. So in theory this is what I want to have, but I'm not sure if I'm going to get it. We'll see. Of course it doesn't compile, of course. So, and location requires what do you want from me? I don't know. That's what I'm talking about. Like it's really unclear what it wants from me, because it just works. And why does it say anything about location? Because it worked before. You think so? It requires explicit location? Okay. So if okay, so I can put all right, layout location 1. But it was complaining about vertex, right? So and in probably also requires explicit location, so we're gonna put it like 1. Oh yeah, so that means if it's a explicit location, it doesn't depend on the names of the variables anymore. You can name it however you want. Okay, that's cool. And what do we have in here? An expected right parent. And this is what I'm talking about. So the arrays are probably initialized incorrectly here. So to initialize array. Okay. Oh, it does it have to be 3? So 12. Oh, it's one of those languages, right? Undeclared identifier. Wait, did they rename it? Okay, so let's try to do an index then. I don't mind, as long as it's gonna work. Okay. Holy fucking shit. Now we're fucking talking. Oh my god. Yes. Kappa Pride. Kappa Pride. My god. It's absolutely beautiful. After 4.5 hours, this is what we achieved. We not only went through the entire tutorial, we went beyond the tutorial. Right, because tutorial didn't show you how to do the shit. No, they didn't show you. They just threw some bullshit at you. We managed to do that. Isn't that amazing? Isn't that amazing? I think it's goddamn fucking amazing. So we extended the tutorial. Absolutely fucking unbelievable. All right, so let me do the following thing. I think it's worth committing. I think this entire shit worth committing. So let me, do I have a readme? I don't even have a readme, but yeah. So let me see. So this is going to be a project. This is going to be a project, and let me copy this is entire stuff in here. So it's going to be pwd based on this thing. It's literally based on this thing. The license that we're going to use. So let me remove all of this stuff. I'm going to put MIT in here. That's a good idea. Maybe I'm going to make a screenshot and put it to README. README. So I think I want to call it slightly differently because this project, does not represent what I'm actually doing. Vulkan, Vulkana, rainbow triangle. Rainbow triangle. Vulkana rainbow triangle. Vulkana rainbow triangle. So okay. Classical rainbow triangle using Rust and Vulkan via Vulkana bindings, right? All right, so let me find the Vulkana bindings. I think this is where they are. So based on the Vulkana triangle example, right? The Vulkana triangle example, and we can put this thing in here. Then we're gonna do it like that. It's gonna be a quick start console, and it's gonna be just cargo run. You see how easy it is? You see how easy it is? It's just cargo run. You don't have to set up anything. It's just cargo run all the way through. All right. So let me try to run that one more time. Probably cargo crawl. So you just do cargo run, and after a couple of hours, you have yourself a rainbow triangle. It's that simple. Okay? It's that fucking simple. Even if you have all of the dependencies compiled, you still have to wait for whatever fucking reason. I still don't understand why. Okay, so oh yeah, when I'm resizing everything, yeah. Wait a second. Script S, and I'm gonna put it like that. Okay, so I'm gonna move this thing here. Thumbnail, and yep, thumbnail, PNG. Okay. Also, I think I need to update the name. Right, it has to be something like this. I wonder if updating the name of the project will trigger the whole recompilation of the project. Okay, we didn't recompile everything, which is nice. Do we have any Vulkan? I don't think so. All right, so let me try that. So if I take a look at the log, how many shed do we have? 1,000 lines. Ready, set, go. Even though we're programming in Rust. Haha. Okay. Wait. Okay. It's gonna be Zozin. More lines for cargo. Yeah. But it costs nothing. Adding a dependency to cargo literally costs nothing. It's that easy. Why wouldn't you do that? It's that fucking easy. Holy fucking shit. It's literally free. Okay. So let me try to do this thing. So it's going to be public. Classical rubber triangle using Rust and Vulkan via Vulkan bindings, and let's just do that. Okay. Hope it wasn't too loud. All right, so this is the result of today's stream. Give it a try. Try to compile it on your machine. Send me your electrical bill afterwards. Anyway. So that's pretty cool. I guess we managed to do something. Vulkan, rainbow triangle and stuff like that. Yeah. So yeah, I guess that's it for the day. I hope today's stream was interesting for somebody. People were asking me to do Vulkan and Rust stream for quite some time. And there you go. I did it. I guess happy now? Is everyone happy now? I did the thing. I did the Vulkan and Rust thing. So maybe it was fun, maybe it was not. I don't know. In any case, I gotta go. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all tomorrow. Tomorrow we're gonna be doing game development in C++ and OpenGL. So yeah, check out our schedule, check out our VODs channel. This stream is definitely going to be on the VODs channel because I need this stream to be on the VODs channel. Every time somebody asks me about Rust and Vulkan, there you go, I did it. May I go in peace now. Thank you very much. And also check out our Discord server for offline discussion with the community. And let's maybe raise somebody. Is anyone streaming any Vulkan and Rust on the science and technology section of the Twitch platform? Is anyone doing that? So let's see. Fourth is doing something. Fourth is doing. So he's doing Elm. What we're not doing function. Oh, well, I mean, we're technically doing functional programming, but I don't know. Strawberry Hacker is probably doing something cool. Making compiler, tokenizer, and compiling expressions. Let's try Strawberry Hacker. I think he's doing some interesting stuff quite often. Alright, so I'm gonna copy paste his nickname and yeah. Day one. Yes. Why this? Alright. Say hi to Strawberry Hacker. Get ready for the read. And I see you all tomorrow. Love you all. Mwah.